recording. Okay, so first thing, we are ditching the objects and we are using structs. Okay, and
Right.
structs, it's basic at least for now, as far as I know, it's basically a container that you can have fields on it, and the structs can implement what is called generic interfaces. Generic
Mm-hmm.
interfaces are interfaces just like before, but they also generate dynamically stuff. So as we did with PPX before, where when you implement the
Yeah.
XML or JSON, you get a bunch of functions dynamically generated.
Mm-hmm.
You get the same with the interfaces. So generic interfaces, sorry. So
I see. So you would implement the interface and then magically have access to some
to a
functions that.
predicate that asks stuff
Oh, I
if it
see. I
has
see.
implemented the serializable interface.
Biteable.
Yeah. So then what I did, I converted all the normal interfaces to generic ones.
Mm-hmm.
And then because now we have the predicates of this stuff, we can make what it's called a contract, which is a runtime checking of the type signature of stuff. So what we are doing is saying that in order to you to be able to use serialize, the
Mm-hmm.
first thing that needs to come is
Okay.
something that implements serializable.
Mm-hmm.
Optionally, it can send an optional argument called size, which needs to be an integer, and the output always needs to be bytes.
So the arrow star there is that the optional part?
Yes.
Okay.
And then, because this is inherently immutable, because actually you were not here because you were in vacation, but I explained to Marinho, and the 30-second version is that 99% of the serialization was done on like last week Thursday, and then I was doing finishing touches and I discovered a bug that was because of mutability. So that was the breaking point in which I said screw it, let's just rewrite this. Um,
Okay.
so that's another thing. Structs are inherently immutable. Okay, inherently immutable, and this
Right.
Yeah,
is go on.
No,
yeah,
no.
you can
That's
declare
fine.
a mutable field if you want, but that's not the default. The
Yeah,
default is immutable, so
Mm-hmm.
yeah,
it actually
exactly.
has the right default. So
Right.
you know,
Yeah, exactly. Okay. So what are the main? So this is I already talked about generic interfaces, structs, and contracts. That's the three abstractions that we are using. And the only thing that I want to mention that is a little bit detailed is that before we are using that mechanism of having a superclass with a deserialization of hash lists being shareable between all the subclasses. Because we
Mm-hmm.
are ditching that, now they are just functions with contracts.
I see. Mm-hmm.
So if you want to use a deserialized hash list, you need to send something serializable,
Mm-hmm.
something that is bytes, a list, and yeah, we're going to return you another list. And the same thing goes for the serialized hash list. And that's basically the entire. So everything from this file and everything from this file are already converted to this new way of doing. And again, as you said, you can read the code later, but it's very straightforward. The only thing that we are missing from here that we actually never had before is the fact that we are not checking, and you can do that with structs. You can add conditions that will validate that the fields needs to be of a certain type. So if you want something to be a number or a string or a list,
Yeah. Okay. That's
you
pretty
can
good.
just add guards that will always validate. Again, it's not static validation, but it's
Yeah.
going
Yeah.
to be a validation anyway.
yeah,
This needs to be a number or something along those lines.
and guards are not just validation. They actually allow you to arbitrarily transform the struct input. So
Yeah, they
I mentioned this
validate
earlier.
and they do custom construction. So the constructor would have some sort of customization, such as what Marinho said. If you provide me two numbers and you want a fraction, the guard can already do the simplification to normal form of the fraction. So you can do
Yes,
stuff
I
like that.
actually have an example of that in the RacketowerDB channel. If you scroll up a bit,
Yeah. Um, so there are a few things that are still missing. For instance, this function here, this was a method of the field class before, right? This was one of those, but because I didn't know how to do it by myself, I decided to just make it a function here. But this should be related into some degree with this.
uh, by the way, uh, I think I mentioned this earlier, but um, after you linked me the F sharp version of the DB from Mageta's GitHub, did you you know did you actually change the structs so that it actually follows the code there? Because there
No, I
shouldn't
did.
actually be a.
No, I didn't change. I didn't change because I think we discussed that if we want to follow Mageta's design, every single some
Oh,
case of the ADT would be a
which is a
separate
bad
struct,
idea, by the way. Which is
which
a
is a
bad
bad
idea.
Yeah,
idea.
Yeah, because
no.
I did that when I was learning, right? I didn't know anything. So it is basically just me guessing what to do.
Oh, okay.
But it works.
Yeah, somehow, yes.
It definitely works. But
No, but I mean, if
what we said on Marinho is that I understand that probably if we want to follow Mageta's design, there are some simplifications and stuff like that. But to speed this process up, because we want to get rid of this as soon as possible, let's just do the most one-to-one translation between what the previous implementation and what we are doing now. And if it's easy and very low cost, we can bring some improvements from Mageta's implementation. We
okay,
did
that's
that
fair.
already. We did that already with the size stuff instead of bringing the type, because you don't need the entirety of the type information. That's fine. Um, anyway, so what we are doing now is converting io.racket. So Mageta, throughout this process, something that I would like you to think about, because you probably already have thought about it before. How do you model the Mageta KL stuff? Are we gonna use like an
Okay.
expression stuff?
So basically, here's the thing. You don't want usually, like if you look at the SQL, the first SQL standard, which I have the paper now, by the way, the definition,
Oh, nice.
but it was for like cheap on Amazon. But anyway, like you for the relational model, you don't require nor you want a Turing complete language.
That's completely fine.
Uh, However, since we are doing procedures, and I think it would be cool if we could do like triggers as well, and to have more usefulness out of it, I think it's better to just go with like some abstractions that break the relational model. So, for example, lists, it's something that is not allowed on the relational model because it's basically violating the first normal form, right? So, like an array, for example.
Yeah, yeah, yeah.
Uh, Languages like Postgres, for example, they do it anyway, right? They allow you to add that.
Mhm.
Uh, and other languages like SQL servers, T-SQL, Transact SQL, they disallow that for the types. So, for example, so at least on the tables you cannot do that. You see what I mean?
Yep.
To be honest, I think just doing for the but I also think that like doing some sort of stuff like serializing lists for a table is going to be awful. So I know how, but it's going to be awful. So I think we better just stick with a normal expression-based language. Uh, but with like a lot of things trimmed down. Let me just see what Nathan sent here. A bit hard to avoid sometimes. Yes, I agree.
I don't think, but
So
not in this case, Nathan, because like if you just do SQL, it's completely fine for what we're doing. If you want, I think they have a different name. I think it's this or something like that.
So what I think is the best approach here is to make it as if it's expression based, but you know how Prolog works?
Yeah.
It is by every expression, let's call it like that, is true or false, right? So it's all propositions.
Yeah.
So as you write, you're actually writing a theorem, right? So
Yeah.
because think of this, you're providing a proof. Sorry, you're actually providing a proof for something because in theory you would get values out of it, right? With a query.
Mhm. Mhm.
So that's the idea I have in mind, which is to just make it as if it is a expression based, but in the end, the terminals need to be valid, true values. That's the idea.
No, I'm completely down on it. Like
Reducing side
that's fine.
effects.
But
That's
what I want you to start thinking about while we do this translation here, because I think this will be too boring for your mind. Just think of the ADT or whatever you decide to model that
okay.
of
So
the expression-based grammar slash.
I have some sketch on my head, but I need to, well, to make it better, I will probably have to sit down and think about it, right? But to get started, do we have something already on language? Can you go there?
Yeah, we do have something already in own language, but it's very bare bones. Like because
Right.
that's the thing. When we were doing this, we didn't have any sort of expression knowledge. We started to go through that barrier when we decided to add predicates like select.
Oh, right, I
So
see.
when
Yeah, I
we did
remember.
we hit this barrier, I said, man, how are we gonna model this? We don't have expressions. What is this? What is this?
Mm-hmm.
Uh, so then like we stopped, and I think that if we want to go forward, we need to discover, not to discover, to set on how to we gonna translate this.
Oh, I saw mini common. That's pretty good. I saw it when I was looking for logic programming.
Logic programming, yeah, that's something that I need to understand there. Oh, I
Mm.
think, oh, this is the book that you told me that is cool.
Yeah,
It's
yeah.
Bluebees.
I think I even added to my cart on Amazon.
But folks, just one thing. I didn't have dinner yet,
Yeah,
so
go
I'll
go
go
yeah,
down
go there.
to the back. But do you have things to do now?
Yes, yes,
Still?
yes. We're gonna finish translating this.
Okay, so I'll be right back then. And
Okay.
then I'll try to make a grammar with Nata, probably.
Okay, Marin,
Be right back.
look at this guy. Do you see the problem?
Let's see. Get field, identifier. You have an entities list. You take the first element of the list, and then you take the rest of the first element. That doesn't seem right.
Trust me that it is, but that's not the problem.
Uh, right. You have an identifier, which I imagine will end up being a struct or something, right? And
This is
then,
actually a field of two structs, table and
okay,
procedure.
okay.
And now the problem is, we don't know what is this, right? So my understanding is that I can just do this and it's gonna work just fine. Is that correct?
No, because
It's kind of
I
similar to
don't
the
think.
problem that we had before up here. Because we don't know what literal is this, right? And we want to serialize and we want to pass this argument there. It is kind of the same thing here down here. We don't know
Yeah,
what entity is
except
this, but we know it. But we want the identifier of it.
we could define another generic interface for that, just for that, but that seems a bit heavy-handed.
Oh yeah,
If
that's
you
true,
know,
right? The serializable is actually an interface that. Okay, now it makes sense why we can't just do this here. Go on.
if we know for a fact that the value will be either what did you say,
A
a
table
table
and a
or a
procedure.
procedure,
Yeah.
yeah. If you know for a fact that only those two types will come in, you can do static dispatch. If it's a table, you get the table identifier. Otherwise, if it's a procedure, you get the procedure identifier.
So you're
And
asking me to put a predicate on this and then
yes,
check
that's
what.
an option.
That's an
Yeah, that's an
option.
option.
What
If
are
you
the other
don't mind
options?
yeah, if you don't mind static dispatch, that's an option. If you do mind it and you want to make it generic, you can define another generic interface with an identifier method
Nameable?
and then
Are we going there?
nameable. Yeah, I guess.
Oh boy, oh boy. Okay, that's one of the things that the cursed OOP brought us that I'm missing. The fact that I just can call send and the whole inheritance takes care of what the heck is going on there. That's convenient. I'm not saying it's better, but that's convenient. Um, so let's
Yeah.
go.
If
Let's
this
go
was
define.
closure, I would have just used maps from the beginning, and then that wouldn't be a problem because it would just be a key with the same name in two different maps. So.
It would be just what? Sorry.
If this was Clojure, I would have just used maps from the beginning, and that wouldn't be a problem because it would just be two maps with the same key name, you know? It would just work.
Yeah. But that's going to the like you can do the same, yes, but you're gonna have problems with the maps at some point as well.
Yeah.
Okay, so we want to actually ask. I'm gonna export identifiable anyway. Identifiable.
Um, I think, let's see, identifiable. Yeah, your definition of the generic interface is backwards. The give identifier is the function name, right?
Is the function name? Yeah. What is wrong there?
It's in an arguments position. It's not a function name in the declaration. The function name
Oh,
comes first, man.
this.
It's a
Yeah,
list.
yeah, yeah. I forgot about that. I just followed the patterns down there and I got confused. It is identifiable. Okay. So we're gonna say that give identifier. You're gonna provide me an identifiable. We don't need this. And I'm gonna give you a string. And that's about it. So now let's go to AST. Let's go to table, which reminds me that these provides are wrong. Okay, cool. So let's see. So I want to say that I want to implement something else. So I'm gonna say that we have that. Identifiable, and then give identifier, and then this is gonna be just table identifier
Identifier
self,
of self. Yeah.
and then that, and then that, and then we are done.
And you just removed the implementation of. Oh no, you copied it. That's fine, I guess.
And we gotta do the same with the other guy here, but instead of
Except it's the
table,
procedure identifier. Yeah.
yeah. Man, it's been a while. I think like 2 years since I wrote a procedure in SQL. In SQL. That's a long time. That's a
Man.
long time. Okay, let's go back to our stuff. So what do we
Yeah.
want
Now
to do
you
here? Now
you
we can
can
just
just
do this, right?
call give identifier. Yeah, that works.
Okay, that's pretty cool.
Why why did you name it give identifier instead of just identifier? Is the question.
Uh, I forgot my thought process that I ended in that conclusion.
Okay. Um,
Anyway, so we need to get rid of this guy. We need to get rid of that. We really do need to get rid of that. So what are we doing there? We are just using this this is the problem. Nathan, are you there? This is the problem. Look at how cursed it is. I want to use this implementation, right? I want to use this implementation. But I don't know which entity I have because this is being at runtime being discovered. I don't know if this is a table or a procedure or triggers or whatever. But I know it is something that's going to use the serialized hash list stuff. So look at what I have to do. I had to create a strawman, like an empty dummy object, just to be able to use this crap. Ah, is this off? Yeah, you could do that. You could actually. Jay-Z suggested, not suggested. He said that in the most cases in his experience, people just copy paste the interface implementation twice or n times, right? Multiple times, to avoid this sort of situation that it is this. Anyway, so I forgot. So
uh,
what? Why do we need this? So we are grabbing the name. We want to
yeah,
write the
because you
schema
wanna
down. We want to write the schema down. The schema is a hash map. What we are doing with that? We are okay. So this is a sub function. This is a sub function. Okay, that's fine. So this is grabbing an entities list. So I guess this is like a list of tables or a list of procedures, right? Yeah. This is definitely it. And what we are doing is we grab the name out of the first one because the names will be the same throughout all of them, and we know it's as a table. We serialize the name because we're gonna write it down as well. We're gonna write it down. Why is this being created, by the way? I think I dropped this when I discovered that I can just do that. Probably, yeah. Do we need serialized name in this scope? I really don't think so. Yeah, we don't need
It
this.
it looks like a dead identifier, like it's defined, but it's not actually used.
Yeah, I think
So
before I
that
was
should
using
be
write
fine.
bytes here. That's why. Anyway, so we are grabbing the entity name to know what is the class that we're going to serialize, right? That's the purpose of this thing. So we have this hash map which has all our structs, right?
Yeah.
And the question is, do we still need to use that? I think we are using entity structs now. You're using entity structs. I don't think we need the make object stuff.
No, we don't. Uh,
Then the question becomes, we don't need the send anymore, right? We don't need the send. We just need serialize hash list blah 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 blah. But I already forgot the contract for that. So what is the contract for you? Here. The contract for you is to send something that is serializable, which probably is going to be the new entity, right? But now I'm asking myself, do we need? Because in the implementation we're not using self, if you recall. We're not using
let's
self anymore.
see. We're not using self anymore, so we serialize the value, but that's not a self. So let's see.
Why do we need that? Let's go to the original implementation. I'm getting worried that maybe I translated this wrong. So let's take a look. So this is the same thing, but in cursed OOP. It's not big, so we can try to read it. So
It
you,
takes It's a method, so it takes a this, an implicit self. I'm not sure
yeah,
what's the actual name, but
yeah, but we
anyways.
look at that. We are not using this, and we're not doing any get fields, and we're not doing anything like that, right?
Yeah, it doesn't look like it
Oh,
actually.
it's because of this, right? It's because of that.
And decoder of the named value, which comes from the named values list, which is actually the second argument, not the self. So yeah, we probably don't actually need the self argument.
I think we got a problem actually. Let me explain. This was a miss. Uh, oh. Okay, let me explain. So do you see this guy?
Yes?
This guy is we have a list of pairs, right? This is a list of pairs, okay?
Yeah, because
The
because I
values, the second values out of these each one of these pairs, they need to implement serializable. That's the
yes,
gotcha.
yes.
And why this is here? Because this self is always going to be the type of the second value out of the pair. That's why it is in here. But I believe there is a better way of describing that. We can just drop this like that. And then I have a question. Can we say to Racket to verify that this is a list of pairs of strings and serializables?
As a matter of fact, I think we can. I don't recall off the top of my head, but I think we can. I'm pretty sure there's a list of contracts that's
If
higher.
if that's the case, that would be awesome. That would be very awesome. Right? That would be awesome. Okay, so we need to search for that. Let's search it.
Let's see.
List of Racket.
Here.
Already? Okay, let's look into that. List of Do we have pair off? Do you know?
I think we do actually. Pair.
Okay, this is getting pretty close to like 100% worth it. There, and then we need a pair off. I'm just gonna
I
type
think
it
there's
down. No, it doesn't seem to be a thing.
I mean, there's a type called pair off in typed Racket, so there must be a pair contract. It's just not called pair off. It's probably something else. Let's see.
Yeah, typed Racket seems to have that. Ah, okay,
Mm,
a pair.
oh, found it. Found it.
What's the name? Okay, cons C. That's a
Yeah,
weird
because
name.
you. No, it's not because the slash C stands for contract. There's a lot of contracts with that slash C suffix.
Uh,
And the cons is because how do you build a pair? You call cons, right? So
Look at that, my friends. Let me just confirm. Yes, it is a string in fact. Okay, so look at that. This is so much so much better. Just look at that. Okay, so what does that mean? That means that we don't need this curse anymore. Uh, we don't need that, and we don't need that as well, right? We don't need that as well. Then you can just send me your list. I'm so fucking anxious if this is gonna work because you're not testing at all. We're just going YOLO. So let's cross our fingers that this is just gonna work. So let's correct indentation. I was probably doing that because I was commenting out and adding prints. Let's keep going. There is a get field here, so probably something is wrong. Probably there is something that is wrong. Okay, so this is gonna be a give field.
Oh, I'm back.
welcome back, and I will be right back. I gotta check
Bye.
something real quick.
Right, Nathan, right. Look at this, Mageta. Look at that.
What?
Look how beautiful this contract is, man.
That's a very weird thing to say, man. With, yeah, I think so.
Yeah, this is so good.
C is the contract.
Yes, yeah, the slash C is for contract.
Let me pick the book that I base all my decisions and all my life based on. SQL Pro internals. SQL Server Pro internals.
This is gonna
I
be a
wake up
table.
and I say, what will I do today? That's my astrology.
Okay, that's gonna be that. And
I
you're
build
right,
the language.
Nathan. It's really similar to our notation of functions in Spot in Silverware, which is really
I'm back.
impressive.
I'm back.
Hi.
Oh, maybe that's a natural way to think about it.
Racket agrees. Racket agrees.
Let me see if I find on the book, man. That was
Okay, the
a
writer is done, I think.
query language.
Writer is done. So let's go to the reader. The reader has only two
I,
functions, but really big functions, I think.
I mean, about the arrow thing, it's a list, right? So the operator goes first, and traditionally, when you work with a typed language, you use an arrow for function types, right? And Lisps allow you to have arrow as a symbol,
No,
so
yeah,
it's
that was
kind of.
exactly our thought process, and we decided to make our type signatures follow that.
So I'm thinking here, I don't want to interrupt you,
Go on.
but I'm thinking here, instead of focusing on making a language, why don't we just do the bare bones so we can query something? Very, very dummy, like query things in a table, like a select star.
Okay.
And then we do the other things that I think, because here's the problem. It profits you nothing just creating the abstractions in the language if you don't have the mechanism to represent.
Yeah, but my worry is that we're gonna have to change the mechanism radically when we decide to go full blown.
Not at all, man. Because
I
here's
have no
the
idea.
thing. Here's the thing. The query language we're gonna have to translate to an intermediary instruction by instruction based. Uh, that's what I was calling bytecode. It's not really, but I think that's a easy way to see. Which is a way to think of it is uh, you have you have your data, right? And then you have all the weird mechanisms to fetch it back and to mutate it to operate on the data. And then on top of that, you have a language that allows you to manipulate this behavior. But this behavior is not a direct map between the data and the thing.
Oh,
This
I
is
see. I see what you're talking
dissociated.
about. I see what you're talking about.
There is an extra layer atop of it that we still have to do. So I think it's better to do this mechanism. Uh, well, some of these intermediary mechanisms before doing
That's completely fair. That's completely fair.
And to be fair, doing the language, I don't think we're gonna expose a lot of this stuff to the language, so it's not really a big deal.
Yeah,
By the
no,
way, if
that's
you want
true.
to see the grammar of a create table, let me send you.
Sure.
Create table. TC.
Okay. Okay, let's continue here, Marinho. With our, we have two functions, man. Two no, three. Three functions to finish. The last one is big, but it's gonna be fine. Sure. Okay, so this function here, this is the function that basically just calls the deserialized hash list. And looking at the contract of it, it first asks for something that is serializable, and that
Just
is the
open the
thing.
code I sent, by the way.
Sorry?
Why does
Just
Oh,
check.
oh,
On
you
Racket
sent in the
Tower.
other channel there. Okay.
Racket Tower. Yeah.
Okay. Expand. Oh wow.
This is to create a
Quite big,
table.
right?
question? Is this a context-free grammar?
Yeah. I think yes. Let me see. Pay attention.
Yeah, that's
Yes, it
big.
is.
Man, am I the
Yeah.
only guy here who is who likes peg grammars? Is that it?
Peg grammars is like context-based grammars.
Uh, they're kind of like context-free grammars, except not really, because the choice operator in a context-free grammar is unordered, like the order doesn't matter. But in a peg, in a parser expression grammar, it actually does matter because it tries each option from left to right, so it stops at the first one that succeeds, and it doesn't backtrack anymore after that.
I see.
It's the parsing expression grammar.
Yeah.
The other is the I forgot the name. CFG. Context free grammar. Man, there's like 222 lines just to create a table. What the heck? Okay, to be fair, there's a lot of garbage here that we don't need. And it's shared across other stuff like index option, ledger option, table option. You can like do XML compression. Okay, that's
What?
pretty funny. Man, the amount of stuff you have in like these old ass databases like Microsoft SQL Server is just insane, man. I never see this to amaze me. I think you can stay like 10 years studying one vendor and you still don't know what it does.
Man,
It's like
that's
Emacs, man. Except you can tweak on it, right? That would be really nice. A database on Emacs, right? That would be really interesting.
Haven't you
Like,
tried to do that?
no, I didn't.
Oh,
I mean, I just did this.
I need to show you this, Magetta. Do you remember that when you were doing your OCaml in eLisp, I suggested to make it named
Oh,
eCaml?
yes, I did.
That is
I
a
saw
thing.
eCaml.
That is a
Yes,
thing.
I saw a project. Yes,
It's a thing.
writing Emacs plugin for eCaml.
Ah, that is a thing, but it's completely not related. But like,
Yeah, the name,
the
right?
name is the thing. Look at that.
By the way, I was doing a Emacs plugin on the HP server in Emacs, not the. But then I was doing with C. So I was writing the multi-threaded stuff on C. So because Emacs doesn't support, right? So I was writing on C and then trying to share the library. And then Emacs has a good API for uh well, for C at least. It has a good interface. I don't know about OCaml. Could
Yeah.
be
Marinho, I
bad.
have a question for you, man.
All right, ask away.
Okay, so if you go to the, I really hope I pushed what I'm changing right now. Please. I think it is okay. Read, no. Ah, fuck. Okay, so it's not in here. Are you kidding? Okay, so this is definitely
Are
not a
you
joke.
are you
Oh no, no, but
pushing
it
to
is here. What I
master?
what I carried it is in here anyway. Okay, so look at this. Remember that the previous mechanism was to do a lookup in a in a in a hash map of classes, right?
Yes.
Using the name that we are, because now we are doing reading. We already finished migrating writing. Okay, so every theoretically speaking, we can write everything again, once again, both values and schemas and entities.
Okay.
What we are doing now is reading the schema, as far as I can tell. Yeah, this is reading the schema from the disk. So how does that work? If you recall the file format, you're gonna remember. You need to remember that we have the names of the entities that we are about to deserialize, right?
Yeah.
But that's the thing. We don't know how to deserialize a procedure. Um, in the sense of um, we don't know what's written in here, right? So you need to read this, and throughout the deserialization process, you're gonna read the identifier and deserialize accordingly. Okay. So how we were doing that before? We were doing that before using the cursed mechanism of creating a dummy object like that with the
Yes.
class name, with the class name, and just to be able to call the deserialize hash list. Okay?
Okay.
So when I was doing the rewriting of this thing, because it's using a for and it's using a set bank, so I really wanted to transform it to a fold, and that's what I did. Um, so it is a fold, but look at this. That function there that was doing the cursed thing, it lives in a separate function. So here it was class name, and then this line would be make object of the class name. How do we do the same with a
Okay.
struct? Because we still have the hash map. You remember we are still using the macro that when you create a struct using our keyword, let's say, we're gonna save how that struct is being defined for later. Okay. So how do you
Okay.
do that in here?
Let's see. You're trying to build a value, right? You're deserializing. So you
Yeah,
don't have
this.
a value yet,
Yeah, but look
but
at
you have.
here. Just 1 second. You may ask, we don't have a value yet, so this self is smelling, and I would agree. But then we have a problem. We need the self to be able to know how to deserialize accordingly.
Go back to the define serializable macro you wrote.
Sure.
I think if my memory is right, we are actually stashing the struct type descriptor
Here.
in the hash map now, right?
Yes, we are now saving the name of the struct actually.
Name of the struct. That's not quite right. What we really want is actually the struct's type descriptor, which means uh, yeah, that's a slight problem. We're actually going to have to break out syntax case if you want to do this properly, because the symbol, the value you actually want to put in the hash map is not the struct name. It's actually the type descriptor, which is struct colon and then the name. But that's not
So
actually a symbol we're taking as an argument. So
There, but
yeah,
let me tell you the other idea that I had. Actually, this defined syntax parse rule, the Racket people from the Racket server convinced me to do, because originally what I really wanted to do was to use eval, because I wanted
yeah,
to transform a piece of string, right, to which is just a string to a constructor name, just like new object or whatever.
yeah.
I wanted to do that. But then they convinced me to not do that because it's kind of cursed to use eval apparently. Uh, and then
Yeah,
there's
most
Yeah.
yeah, most people who work with lists will tell you the same thing. Don't use evolve. That's not idiomatic in a macro-based list. In fact, the only kind of place where evolve is something you want to use is if you're writing a repo or if your list is Fexper based, which is not the case for most lists. So yeah, don't use evolve.
yeah, but I am completely open to a suggestion here. We only have two solutions right now: eval using converting a name, a string, to a key, to some sort of constructor, or using this thing here, which is saving every single struct that is being constructed with this key, with this thing, and all of ours, all of them that we are creating are using this. We are actually saving them into a global hash map that we can consult, right? I'm not pleased by any of them, any of the solutions, but I don't have any other
Uh,
solution.
I mean, the hash map solution is something we can work with. It's just you can't actually do it with just a syntax rule because, as I said, the symbol you actually need is something that struct will create, which will be, struct colon and then the name of the struct, which is not a symbol we get as an argument, which means we cannot actually use syntax rules for this particular macro. We actually have to write a syntax case macro for this particular case because, as I said,
No,
syntax
that's
rules,
okay. That's okay. That's okay.
yeah, because syntax rules, it doesn't allow you to break hygiene, which means um, you can only use identifiers that are provided as arguments. So that's, you know,
Wait, can you repeat the last part? You can only use identifiers that are provided by as arguments. What do you mean by that?
basically the way syntax rules works is that it's a kind of it's a micro definition system that preserves hygiene, which means it kind of allows you to it kind of forces you to respect lexical scoping.
Mm-hmm.
And the way it accomplishes that is actually um, there are a few restrictions on what you can do, but one of them is that you cannot arbitrarily insert identifiers into the code you generate. If you want to use an identifier, you have to take it as an argument
Which is what we are doing
to the
here, right?
macro. Yeah, not quite, because the name is an argument, that's true. And then we pass it to struct. Struct is not a syntax rules macro, it's a syntax case macro, which does allow you to break hygiene, which means it can actually define a bunch of symbols besides just name. It actually does define a bunch of symbols besides just name.
Okay.
And actually, we're interested in one of them, not name exactly, but one of the symbols that struct defines for us,
Okay, so
which
let me see if I got it. Using define syntax parse rule, we cannot have access to the side effect of this thing.
uh, it's not quite a side effect. We do have access to the side effects in the code when it's running. It's just that when we are generating the code, which is what define syntax parse rule does, when we are generating the code, we are not allowed to build an arbitrary identifier and inject it in there because it won't be bound to the same. It won't share the same binding with the name that struct creates for us, which is a problem
No, no,
because
no. But that's the thing. What you're saying, calling that the naming, the struct creates for us. That's what I'm calling the side effect because I'm not writing this. I'm not writing anything. And the system itself, the runtime or whatever the heck it is, it's
yeah,
creating more
actually
stuff that I'm asking for, right?
yeah, actually struct is a macro and it does create more stuff. then you're
Yeah, that stuff
writing
that is
there.
being created, that is the set that we don't have access to.
Yes, yes.
Okay, okay, I see.
Um,
So why does using the define case syntax case rule changes the scenario there?
because syntax case is a bit more powerful than syntax rules. With syntax rules, you're basically limited to basic templating. With syntax case, you can actually use arbitrary code to generate the syntax. It's just, it's a bit more complex because it's more powerful. So you
Okay,
have to do.
let's try that. Let's try to read what the heck is going on here. So let's see. So I guess this is the name, right? This swap thing is gonna be the name.
That's the name of the macro. Yeah, we.
So next question. Does it? I'm assuming this is gonna be the same thing like this. Am I correct?
No, you are not. Uh, and with syntax case, actually, the way it works is you. Uh, well, let me back up a bit. With defined syntax, you're defining a function that will be available at macro expansion time. And
Sure.
then that function will have to take a syntax object, which is its argument. So it's traditionally named stx for syntax. And then you have to call syntax case on that syntax, stx. And then what syntax case does is it allows you, it's basically pattern matching on the syntax,
Yeah, it really
except,
seems like it, right?
no, it really is, except the right-hand side of the pattern is actually not just a template, it's arbitrary code that you can write that does whatever you want, basically.
Okay. Okay. So my understanding is that we're gonna go here and write define serializable
Okay,
name
I've
body.
got an idea of what to do, by the way. I think we can start next session if you guys finished here. I will try to do on my own first to
Sure.
see if I can do it.
Sure. Actually, one of the things that I want to mention to you, Mageta, the mechanism that you suggested, right? So the thing that's gonna be called after the language is made, right?
Mm-hmm.
That. So are you proposing us to make like a select of sorts in the form of a function, right? A select function that you pass the entity, you pass the name of the fields that you want, can be a list of fields or whatever, and then this function will be responsible to doing a lookup in the data of that table, and then searching for those fields. Is that what you mean?
Wait, I couldn't parse what you said, man.
Okay, so do you agree that what you said before about there is another layer before going to the language, which is the
Right.
mechanism that does the stuff internally, right?
Yes, which gets accessed by some API.
Exactly. So the thing is, I was thinking about making that a set of functions, right? So you can have like a
Mm-hmm.
select function. Well, not a select function because that would be confusing with the MagetaQL later. So maybe a project function.
Yeah, I think I see. So that's what I call the API.
Yes, yes, that would be the API. That would be the API.
Okay. So
Yeah,
what?
we are about to
Uh,
finish here, so you can start writing yourself in Emacs. And after, yeah, because you love Emacs, of course.
yes, I'll write an Lisp, right?
No,
It's
not
gonna
in
finish.
eLisp. But it can be in eLisp, that's fine. And then we are just gonna finish this reading process and then
Yeah,
change the
no,
main,
no
and then we're
problem.
done.
Let me see here.
Marin, question,
Right?
question. So I am pattern matching. I think this is gonna always be true, right? Define serializable name body. What am I doing from here on?
Uh, moment.
Actually, I'm a little bit curious. How is it using that in the... Okay, there isn't a good
Okay.
example of that. Awesome.
Um,
Thank you. Thank you, documentation. Like, this is the
yeah,
most
no,
generic pattern matching ever.
no, it really is just pattern matching. But
No,
but the
but
way
there
it
isn't
works,
a pattern that is interesting to differentiate. It's just always one. It is always the very like catch-all case. But okay, go on.
Um, you can put, I'm pretty sure you can put an ellipsis after the body in the pattern. That works.
Like this.
So, like that, yes.
Okay.
Uh, and actually, the define syntax, define serializable name body, that would just be define serializable STX because you're taking the syntax objects. Define syntax is just like define, except it works at it defines a binding that can be used in Mac during macro expansion, unlike define, which is for bindings for runtime, not macro expansion.
Sure.
Um, so you have to fix that, and then for the actual thing that we're going to do in the body in the syntax case, we take the name and the body that comes from the syntax we're matching against, and then we have to do, I'm pretty sure it's, see,
Wait, you said something about me fixing something. I think I missed that.
yeah, in the first line, actually, in the define syntax line, you
Sure.
don't actually put the arguments there. You just take stx because it's a function that takes the AST that will be
Oh, okay,
expanded.
okay, okay, okay. Sorry, sorry, sorry. That's completely true.
And then we call syntax case on that AST, on that syntax, and then
Yeah,
inside the syntax case we do stuff. And then
yeah, yeah.
um, what we have to do is, um, let's see, I'm pretty sure with syntax, fix pattern. That's not quite what we want. Um,
Very cool this pattern matching syntax. It's very cool.
By the way,
yeah, I really dislike it.
Go Magetta.
it's just a random comment. I was looking at the conversations in the past. Right? I
Sure.
think we should really do an operating system sometime, a kernel.
Yeah, I think we should. I think we should. We just need more. Well, I need more time.
Yeah,
I need more time. But
I have time now, to be honest. So for me, that's not a big deal. But
no, if
yeah,
we have time, we're gonna start protocol. That's the goal.
oh, the game API.
Yeah,
I even forgot about that.
yeah, we need to start doing that.
Let's
I
see.
mean, it's not
So
bad actually. Anyway, keep going.
Go Marin.
yeah, so for the body of the case we're matching, we're basically gonna copy the begin and the struct and the hash stats we had in the previous version, except we have to build an identifier using the we have to build an identifier to inject it there. And the way it works, let's see,
Wait, you're
there's
saying
one
there it's here, right?
syntax. Yeah, you basically copy that code fragment and put it in place of the example that's up there. But
Sure.
then, yeah, just paste it over there. And then I'm trying to look up, I think it, let's see, datum, I think it's datum to syntax. Takes a context and then a value, which can be anything. Okay, I think I found the function we need. Right, so let's see, quasi syntax. Right, so you want to change, you see the hash quote where you're building the syntax that we're replacing in
Yeah,
the macro body.
yeah.
You want to replace that with a quasi quote, so so we have unsyntax available
What's the
because
symbol for quasi quote?
The back
it's the
quote, right?
backtick, just
Oh,
backtick.
backtick. Like that?
Except you want to do a hash backtick because it's quasi syntax, not quasi quotes. And then And then down there where we're doing hash chat, entity struct, symbol to string, blah, 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 the name we're setting there, yeah, that name. We're going to unsyntax, which is hash comma, and
Sure.
then we're going to call datum to syntax, which is written like, yes, that. We're going to call that function. You should wrap it in parens, and we're going to pass the, let's see, I think we have to pass the name as the first argument, which is basically the syntax we're going to use as the context to uh, that we're going to use the lexical context basically, so we can actually inject the identifier we want, and then the second argument is the value we want to inject there, and we actually need to build a new symbol, which I'm pretty sure there should be a symbol function in Racket if I remember right.
I'm a little bit. Wait, I need to read what datum to syntax does again. One sec. Datum to syntax. I already searched that. Converts the datum v to a syntax object. If v is already a syntax object, then there is no conversion. It converts a datum.
Datum is just an arbitrary value. That isn't
Datum.
syntax actually.
Ah. Okay. Okay. I think I see. Go on.
Yeah, they're being pedantic there. Datum is the singular form of data. So,
Sure.
yeah, so the name will be the context we're going to take, and then we actually need to, I think we have to call syntax to datum on the name, like put a let as the second argument. We have to take the names as a symbol, which means something like, let me just, yeah, the second argument will have to be something like this, basically. Let identifier be the, and then we would have to do something like, man, I kind of, this is one of those times where I kind of miss Clojure's str operator, where it's really easy to just concatenate a bunch of stuff into a string,
Oh, is
which would
that
be
the
really
name of the
convenient.
operator that I asked you about last week?
Which one?
Like that I wanted to make an HTML thing concatenating strings. I think it was
Um,
last week. Is that like column less than greater than? Is that the operator that you want that you were talking about? Marinho? Maggot, are you there?
Yes.
Okay, I think we lost Marinho. I think we lost Marinho. He has a
He's
internet
having
okay,
internet
so my
information.
internet decided to hiccup slightly, so
Yeah, that's not a problem.
um, anyways, yeah, str for HTML templating enclosure, not recommended. There are better ways to do it. Let's see. So yeah, you have to do a let for the second argument of datum to syntax. You actually need the symbol, that name,
Oh
which
wait, we're gonna have to do a
is,
let in the second argument, like just type it down,
yeah,
like let, like this.
Yeah, you're doing a non-syntax, which means that actually that's just arbitrary code that's going to run at macro expansion time. You can just do whatever.
Sure, what do I do in this let?
We have to turn the name into a datum. It's a syntax. We need the datum because we want to convert it to a symbol, basically.
So you're gonna have to
Um,
convert to a datum. So syntax datum.
of the name, yes.
Sure.
And then we can call that the identifier because that's the identifier that we have as an input.
So this is gonna be what? Datum name.
That's not how Racket does the let syntax.
No, it is. It allows you to do that, but I know that they use brackets and whatever.
Yeah, you're missing a pair of parents, but anyways. And then we actually want to build basically name will be whatever. Um, let's assume that you're uh, let's just pretend that name happens to be the symbol whatever. We need to convert it to a string, and then we have to concatenate struct colon in front of it, and then convert that to a symbol. Yeah, that sounds about right. So
Okay,
something like
wait. So I need to concat this with column struct. Is that it? Or the opposite?
struct colon actually.
Struct
Yeah.
column. So how does that work?
I think that you have to use something like
Let me check the operations on datum. So datum. I'm gonna assume it's this. Oh wow. Can you do you have
something
operations on
like
that?
something like this. Something like this.
String to symbol of a string append of struct of a symbol to string of an identifier.
Something like that, basically.
Let's see if I understand what the heck's going on there. So what you're doing,
Yeah, the identifier would be the data name. That's the name you put there. I just wrote identifier because I
and I
wasn't
typed the
looking.
thing wrong. Wait, wrong shortcut. Yeah, here. Okay, so let me try to understand. Here I think we're gonna go datum name.
Yes,
Okay.
yes.
Then you are converting that to a string. Then you are appending a struct column on it. And then you're converting that back to a symbol.
And that will become syntax with the same lexical context as name on the datum syntax that's around the let.
Okay, let me try to explain this to you because I think I don't know if I got it. Okay? So let me try to explain and then you check if I got it, okay?
Okay.
So what we are doing, we're defining a new piece of syntax which is define serializable, which has syntax going after. Then we are pattern matching that with the name, the body, and whatever else that comes after.
Yes.
Then I really don't understand the need. What is the hashtag again?
That quasi syntax is kind of like quasi quotation, except it preserves lexical scoping in.
Okay. Uh, and then the backtick is to do quasi quoting instead of quasi. Uh, no, this is to do the quote would be quasi quoting, right? This
Yeah,
is something different. This is what? Quasi what?
it's quasi syntax. It's
Quasi
kind of like
syntax?
it's kind of like quasi quotation, except quasi quotation operates on raw X expressions, so lists and symbols and whatever.
Sure.
Quasi syntax operates on syntax objects, which have source location information in them.
Yeah. Which is kind of like this. How can I say? They are using Racket to be a language to manipulate Racket itself.
Yes,
Okay.
basically.
Okay. Okay. Then you're doing this block of code in which involves defining a struct and saving into the hash map entity structs using the key as the name in the string format.
Yes.
Then you're doing quasi what? What is the comma here?
That's unsyntax, by analogy with unquote, which is an operator that
Okay,
works with
okay, so this is
logic.
basically re-establishing the evaluation of this.
Yes.
Okay. Then you are transforming this piece of datum to a piece of this piece of datum to a piece of syntax.
Yeah, actually, the way datum to syntax works is you take a syntax object as the first argument,
Sure.
and that object will be used just for the lexical context. It will be copied over to the syntax you're building.
Okay, so this is the
So,
syntax that we are building. This.
yeah.
Okay. So it's binding this name to this piece of syntax.
Actually, we're building a piece of syntax on which is the argument on the right, and we're copying the lexical context from name onto it.
Oh, okay. So, oh, I see. So this is basically grabbing the scope of this and putting and merging that with this. This
Yes,
is scope.
basically.
Okay.
Yes, basically.
Okay. This is not a good name for that though, but okay. Then you are basically grabbing the name, which is in the scope again. You're grabbing the name, transforming to a datum, which is, as far as I can tell, a string or a symbol in this case.
Yeah, it will be a symbol in this case.
It would be a symbol. And then you're basically returning the type. What is it? What you call type descriptor?
Yes, because when you call struct on a name,
I see.
it defines a bunch of additional symbols. One of them is struct colon the name, and we're basically just replicating that. So that's the symbol we're interested in, struct colon and the type name. So we're just basically using string manipulation to build that symbol out by hand, because we have the name, that's the suffix, we attach the prefix to it, convert it back to a symbol, and
I see.
and then we
I see.
turn
Okay.
it into syntax. Yeah.
Okay. Okay. So
And
now, let me see
this
if I got it. So this is basically saving to this hash map the name of the struct and its type descriptor.
just the type descriptor actually. The name that's on the left there is just for the lexical context to work properly.
No, no, no. I
Otherwise,
understand that. I'm not talking about
yeah,
this one. This one is just for the scoping. That's fine.
yeah, this
I'm talking
that's
about
fine.
this one.
Yeah,
This is
where
basically like the key is gonna be the name of the struct, so like table, type, whatever, and then what we're gonna the value bounded to this key is gonna be the struct's type descriptors. Only that, not the struct itself.
yes, exactly.
Okay.
And we're doing this because we can call interface methods from generic interfaces on the type descriptor, and that's basically like calling a static method from a class. And this
Okay, so
is
then that's kind of
necessary.
cheating then.
Kind of. But no,
Like,
we're doing this because we're deserializing, which means we need to know which class, or in this case, which struct type
no,
we're
no, 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 no.
deserializing
I'm not saying
into.
in our case. In our case, we are using for a reasonable reason. What I'm saying is that you can use this for evil, right? Because if every single struct method becomes a static method, you don't
No,
need
it
this.
doesn't.
Oh, it
No, you
doesn't.
see, the way it works is there's the the distinction between static and dynamic methods is very loose. Basically, if you take the self arguments from the method and you try to look up its fields, then the fields only exist if you have an actual instance rather than the type descriptor, which means that method is necessarily dynamic. And then if you don't care about the fields, you only care about the type itself, you don't try to access any fields, and that's static because you don't need the dynamic information from an instance. You just,
No, that's fine.
dispatch.
No, no, but that's completely fine in our case. What I'm saying is that let's suppose that I have a struct with like 50 methods, and
Yes,
10 of these methods are very sensitive, right? Like you need to have sensitive in some definition or whatever. Like you need an instance, for instance, to call them
yes,
because they provide you sensible information, whatever.
sensitive
This
information.
trick
Yeah,
here, this trick would it allow me to call the methods even
No,
without an
because
instance?
no, because as soon as you try to read a field from the instance, it's gonna fail at runtime
No,
because
I'm not
the
saying a
struct
field.
type.
I didn't say a field. Oh, but the methods call the fields. That's what you're proposing.
Yeah, if
Okay.
you
Okay.
yeah
Okay.
if the method tries to access any field whatsoever and you happen to be given the type descriptor, that's gonna fail because obviously the type descriptor is just a descriptor. It doesn't have actual fields. So
No, no, okay. If the sensible information is coming from the fields, then you are safe.
yes.
But my worry is that if this allows me to call any all the methods, and if the methods explode a bomb, like you don't need an instance to explode it. You can just do it.
Yeah, if the data required to explode the bomb is in an instance field, then yeah, you need an instance field. Calling with the type descriptor is not gonna work. But if it doesn't, if all the information is attached to the type and you don't actually need any fields from the instance to explode the bomb, then yeah, you can explode the bomb with just the type descriptor.
Oh yeah, okay, so it can be go bad, very bad. Okay, okay, okay. Okay, so all of this that we did just we did there is just for the sake of being able to. I think the intention was to create a struct only out of its name, right? That's what we. That's the problem right now.
Yeah, yeah, basically if you have a struct name, we can look it up in the entity struct map, and then we'll get the struct type descriptor associated with that name, and that allows us to call the generic methods that we want, serialize and whatever.
1 second. Uh,
Um,
one
by
second.
the way, I do not actually guarantee that the syntax case will work exactly because I don't usually write Racket macros because, as I said, I don't particularly like syntax case or really schemes notion of macros because I personally find it a bit complicated compared to just, plain old procedural macros
Yeah,
from
but we
commonly
already
used
talked about that.
closure.
If you want to just have the full power with all the access to all everything, just use I don't know, something completely the only lists of tokens or whatever.
Yeah, no, in this case, it's not really about power. Um, it's about the fact that you have to do syntax case and it's a pattern matching thing, and there's a basically an auxiliary language that you have to learn, and then there's all this datum to syntax and
No, no, but
syntax to
this is not an
datum.
auxiliary language. This is still Racket, no?
I mean, technically, if you want to be really pedantic, since syntax case is kind of like a macro, it's usually implemented. I think sometimes some implementations provide it as a special form, others provide it as a macro, but either way, it's basically pattern matching on syntax, which is not something that Lisps do by default. They just call functions and macros, but you know,
Yeah, yeah, I understand that.
if you consider a macro to be a language, then yeah, that's definitely a language. Is the thing.
Definitely a thing. Okay, but let's assume I'm okay if this doesn't work. We can just fix it later. I'm gonna have to fix a bunch of things later. That's fine. I
Yeah,
just want the bare bones like 90% translation done, so then I can do
yeah,
this offline and then we can focus on primary keys, I guess.
yeah. Okay. Yeah.
Uh,
So the high level idea is there. It's just I may have made a mistake with the details because, as I said, I don't
that's
usually use.
fine. My next question is, where is this guy coming from? And the
Um,
sad part is that I wrote this, so I should know. That's the sad part.
Basically me working every day.
I wrote it, but I don't recall. I really don't recall. Like, where is this class name coming from? Oh, I changed it. It's probably struct name. Okay, it's probably struct name. Um, What I'm getting really confused, like really confused, is the fact
Yes.
that this is grabbing a name. This is grabbing a name. This is grabbing the current schema because this is the folding function, by the way, as you can see here. So this is the function that is grabbing an accumulator, which is the schema, because again we are reading the schema, and this is a line. So this is like we have a bunch of lines of bytes. I think it's entity structs. These entity structs. Okay.
Plural, yes.
So we're basically checking if the key is entity structs. What does that mean? If it is, that means that we are good. That means that we are good. Why? Because that means that we know how to. We found an identifier, and the following lines will be the data. Right? The following lines will be the data. So my question is, what is the hash ref doing here? So is this doing a lookup in the hash?
It's doing a lookup, yeah. It's a schema
So
convention. Basically, if you're doing a lookup, you basically write the type of the thing you were doing the lookup in this case it's hash, and then a hyphen, and then ref for reference, because you're looking up a reference inside of the hash.
yeah, but
And
what
there's
I'm
like,
not understanding, what I'm really not understanding is that if this before was a hash map of names to classes, is this a class? Would
this
that
is actually a, this is now a struct type descriptor,
no,
which
not now, before.
before.
Before this was a class object instance, right? I guess.
Yeah, yeah.
So this would never work, right? Because, yeah, I don't think this would ever work because because the current schema is right, which means that, oh, if this is a line which only contains the name of the entity, with like procedure or table or whatever, that means that the schema is the same. That we only gonna change the schema otherwise, right? So that this is this hash union, whatever the crap is going on, this makes a ton of sense. What doesn't make sense is this. This doesn't make sense. Uh, yeah, this doesn't make sense. So I guess this would be actually struct uh, line, right? And then the thing that I just removed there would go here. So entity structs line, right? Which actually uh, begs the question of putting in a let, right? Because I'm using. Oh, I think it's fine. It's not that big of a thing. So let me explain what's going on here. This is the function that's we're gonna be using in the fold. Okay. What this
Okay.
should do? This should receive a struct name, because imagine that we are reading a bunch of procedures. We need to remember, right? We need to remember that we are reading procedures. So this is the name, right? And we're going to be constantly updating that throughout the process if we detect that the current line is a key in our hash map. This is the
Okay.
current schema, so this is the thing that is accumulating, and this is the element, and this is the element. Yeah. So so I am transforming the line just to be able to check it if it is in the hash map. If it isn't, well, actually the opposite. If it is in the hash map, that means that I'm gonna return as the new accumulator the name of the struct, because I'm gonna use afterwards, right? And that's the same schema that I just received, because the schema didn't change at all. Otherwise, that means that I am deserializing data itself. I'm not deserializing a name, I'm deserializing data. If that's the case, I'm gonna put the same struct name, because maybe the next line will be another table or another procedure or another entity, whatever. And I'm gonna update the schema using a hash union, using the define build from hash line, from line, sorry.
Okay.
So what this is going to be doing, this is going to be grabbing the serialized hash list, the struct instance that we are getting from the hash ref, and the lining bytes, and the initial accumulator for the list, which is an empty list, of course. And then we're going to create a immutable hash map out of that. Okay? So that's what this function
Okay.
should be doing. It should be doing that. So then it comes the main body. This is the body of the main function read from disk. These two things are only auxiliary functions. So the main thing, what is this doing? It is reading the data of the schema based on the schema name. It is opening a port with the data. It is instantiating an empty schema that we're going to use to fold. Then it's reading the lines of the file that we just opened the port for. And then this is the composition that does the actual transformation of the just lines of bytes into an actual schema. So we're going to do a fold for starters. This fold picks the lines that we just read. The initial accumulator will be no struct name, like no struct that we are aware, and the empty schema, which is the one that we're going to be keeping updating, accumulating, right? And the lambda is the following. So you're going to have the lines and you're going to have the accumulator. The accumulator is a pair, so we need to deconstruct that. And then we call the proceed reading. And this is not a builder class anymore. This is going to be a struct. And the current schema. And then we just call the function that I just explained. After we are done, we're going to have an accumulator of a pair of two things. The last struct name that we deserialized and the schema. So we do this, cadr, right?
Okay.
But this is still a this is a list, right? Is this a
It's
list?
a pair. It's a pair.
No. This is a pair, but then we are getting rid of the pair, right? So we are getting rid of this part, and we just have the
Yes.
schema. Oh, I need to do this because this is an immutable hash. That's why.
So basically you're doing it backwards. Instead of using mutation in the builder to speed things up and returning an immutable thing, you're using immutable things in the builder and then you're converting it to a mutable thing before returning it.
Oh yeah, we are converting to a mutable thing because that's the way that we are testing here. We are doing a bunch of sets. Look. So the reason why I did it that way is entirely because in the our use case we are using a mutable schema, a mutable hash map. So that's why I did it that way.
I
And
see.
and that's it. That's the function without using fors and mutation. Uh, mutation we are just using it the last bit. Everything else is just normal stuff. But I think we converted now. I think it's converted to the structs. Okay, so now we have this very tiny function which is basically reading a table data. I think this is reading. No, this is not. This is only reading a table. This doesn't read entities, only tables. So we're reading that, opening that. So we are creating a table out of scratch just to call the serialization. We don't need that. We can just
You
do
don't need that. Just call
this.
deserialize.
Oh yeah, we can
No.
do that.
Deserialize and then the first argument is struct column table and that's it.
Struct column table like that.
Like that. And that's also the return value, so you also get rid of the last line, which just has a table, which is not a thing anymore.
Okay. And then the last function is the function that reads the data. And oh boy, this function is quite a thing. I actually don't know if I want to change this now. I'm actually going to comment this out. Because this is less, we don't need this to proceed. to make the primary keys thing work, we only need the logical thing to work. This is only data, so who cares? Uh, so now we just need to fix the instantiation of the stuff that is going on in this gigantic let, and we are done.
Oh, that's
Oh,
nice.
okay, so uh, let's start by making a field. So what is the syntax again to use structs? I think it's positional, right?
It's positional.
So we're gonna have to remember est. Okay, so the first thing is the position, so I'm gonna put 0 there. And now we need a type. But to make a type, we're gonna have to make it like that. And positionally speaking, the type has the name, which is a varchar, and it has a byte size, which is gonna be 7 in our case. And then that's pretty much it. So I can just do this. Next, so field. How crazy would it be, Marinho, if this just works? It would be a
Yeah,
miracle.
it would be a miracle. I don't think it will just work, but we're close. We're close.
That shows a lot of confidence for what is to come.
That
Uh,
integer, and I think an integer is always 4.
For what is to come, that is
No,
very
but we
nice.
did a very big change, Magita. We did a very big change. We basically transformed to, I think, correct me if I'm wrong, Marinho, but this is what people call idiomatic racket, or at least closer.
yeah, you use structs and generate interfaces, and you don't do mutation by default. That's silly.
What do you mean doing mutation in SML?
How do you do a mutation in SML?
Well, I use hefs like Okamo.
Oh, like OCaml. I
Yes.
heard in the function programming server that SML has some disadvantages to OCaml. Do you know anything about that?
Uh, I mean, the language. I think there's one, which is, well, it's
No one
already,
uses.
yeah, like apart from these obvious disadvantages. Man, do you know how you change the language, by the way? The standard? You gotta submit a paper, and then you gotta be peer reviewed in a conference, and then they do an addendum.
But isn't
Uh,
that because SML is like verified or like correct by some proofs or whatever?
no, yes. The point is, it should be an academic paper, right? It's like if you want, it's not like any crook that can go there and change it. It's designed to be like.
No, but that makes total sense if the language is already like verified to be.
Yeah, but I'm thinking here like it has all the features of Okamo, but I don't think it is worse. But I don't know Okamo that much to say. Oh, what I know of Okamo is because of I know F sharp, so I can't even say that much on it. So I can't say. Just a sec.
Question for you, Marin.
Yes.
Will be Racket be able to know that this is not the same thing as this?
Um, it will for the first one, but then the next time you call table again, it's gonna be shadowed by the previous binding.
Okay, so we're gonna need to do this. Actually, I'm gonna put the real name.
Okay.
Procedure
Dun, dun,
test.
dun, dun, dun,
Then we
dun,
have the
dun, dun.
schema. Then we have a bunch of rows that nobody cares because we don't care about data. Uh, Again, no data. No, 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 no.
This is
Who-
type level programming taken to a new extreme.
we don't care about data. Ah, okay, now get rid of all
You
of
can
that.
make this into a TED talk, man. I'm pretty sure.
What? We
Not a
don't
TED
care
talk.
about data?
Not a TED talk, like a strange loop kind of talk.
No, about what?
Don't think about data. I don't know, man. Just think of some hype title that would attract the nerds
Well, you
to
make
watch.
all the lispers go crazy. That would be fun.
Well, maybe in a
Um.
bad way.
Okay. Okay, so
No one
procedures.
uses Pong, Pong
Programmer.
game, 3D Pong. Oh, I think you showed me this, Nathan. On the browser, of course.
On the browser, of course.
Man, I don't know why I have hopes for Nathan, man. I shouldn't.
Okay, this is all the tests that all of these things that that are commented, Marinho. All of these were to debug the mutation crap.
Man, this is not that hard, by the way.
What, the 3D prong?
Yeah,
I believe you.
do you?
Yeah.
You shouldn't, maybe.
Okay, I think this is enough
Okay.
for testing though. We like these tests that are going on here. Those are great, but I don't think they are special in any sense. And these are the comments to make the server that it isn't still here. Okay, so it's time.
Man, it's very fluid, by the way.
60 FPS.
Yes, man, in Pong. That's pretty impressive.
Are you ready, Marin?
They even
Yeah.
added like funny sounds, like a ball hitting a can.
A classic Lemos error. A classic Lemos error.
Parentheses.
Of course.
Yeah.
Oh, I
That's
know why.
interesting.
It's because I didn't close the module. Because I commented all of this thing.
Lemos, quick question. One
Oh.
of my friends is maybe going to migrate to NixOS. Does it have a Discord
Good luck.
package?
Uh,
That you need to
let's
override
not
every
let's
3
not
weeks.
ask though that question.
That you need to override every 3 weeks. Yes.
Okay, the answer is there is a way to have it, but it's not in a Nix way.
I mean, no, it is very neat. You
No,
just
it
need to
isn't very
override.
Nix to have to
And
do
like
a
the
Nix.
problem is the NixOS problem is Victor said it perfectly. Easy things become impossible, and very impossible things become easy. Like I can configure my EXWM, all the stuff like very easily. But if I just want to do something simple, like for example, you know when Discord updates,
Yeah.
Discord is mutable, right?
Yeah.
So it is like a Electron app. So when it updates, some updates require you to reinstall, right, on Linux. On Debian and other systems, it's pretty easy because they give you the db pkg, right? So you can just go and the deb file. So you can just go there in the package manager and install it, and that's it. On Nix, that's not easy because you need to basically override the package that is defined on the Nix packages to always use the latest from the link they give you there on the website.
Yeah, but that's one line
So
in a Nix configuration. That's not hard.
that's not one line, man. What you're talking about?
My setup is
No,
Discord
what
occupies
you are
one line.
doing? No. What you're doing is probably changing the JSON of Discord to force it to start. That's the one-line solution that I have also, by the way. Because to override, you need to change the package. So it's like at least 2 lines to do that. It's not bad. It's just like, man, like, are you serious that I have to override like a
No, but
package to
I
open
think that's
Discord
because there are some applications that will take a while to
and
become Nixified.
rebuild my entire operating system and possibly compile my kernel because I want to do this?
Because of Discord. That's true. Marinho, look at our problem here.
Right. I think you have to put the hash quotes in front of the name. I'm pretty sure that should work.
Which one of the
Because
names?
both of them
27.
actually.
Both
Both
of
of
them.
them actually.
So you're talking
Yes.
about doing this.
No, the quote. You're putting a comma there.
Oh,
It
there.
should be
Sorry.
a quote.
Hash
And it has to
quote
be
you said.
hash quote. Yes, hash
Yeah.
quote.
What is the difference between doing backtick and doing hash backtick?
When you do a hash backtick, you're building a syntax value, okay? And when you do a backtick, you're building an S expression, so a list of symbols, usually.
Hmm. Wait. Okay, so we have some problem there.
Da, da, da,
So it's
da.
probably a package thing. Where do you come
No,
from?
actually. It's
Base.
from
Okay, do I have the require?
you. You might,
Uh,
maybe, I don't know. We
I
gotta
do have
double
the
check
require.
that.
Okay,
Okay.
so I'm confused. Is this not the way the... No, it is saying define generic as invalid keyword argument. Maybe this is not the syntax? Let's check that. Oh, I hate when that happens. Okay. Requires. Okay, again, no examples. Oh no, there isn't one example.
Not so fast.
Yeah, but look at this amount of text. Look how beautiful it is. Ah.
I mean, you have to agree that Scribble has very nice typesetting.
Scribble, what do you mean?
Scribble is the Racket documentation system.
No, I would say that this is nice,
All
but
right.
what again? What I'm complaining. I wouldn't say it's even a big complaint. It's just that you have things like that don't have any natural language whatsoever, so you don't even know what it does. You only have to guess based on some examples, and maybe the examples will be enough, but maybe they will not. So it's nice to have a three-line description of the semantics of what should be doing there. You don't have to keep guessing based on the name, especially if the name has Haskell style like fold one or fold quote, which is bad. Um, but Racket takes to another level in the sense that it has a bunch of natural language, and for me, it's faster to parse Racket instead of parsing English. But
You're
anyway.
you're becoming quite acquainted with this.
Uh,
Anyway, so the
okay.
require seems to be wrong. Do we have requires? Let me put require here. We do have requires. Am I putting plural or in singular there? I'm putting plural. Okay, so I'm confused. Invalid keyword argument.
Da, da, da,
What do you
da.
mean?
Oh, I
What?
think, let's see, generics opt, then that, and then generics opt. Okay.
What is the generics opt, by the way? Because I noticed that this is not optional.
It's option, not optional. I mean, technically, if you wanna argue into semantics about optional versus no, but it's a generic option, as in it's an option that you pass to the definition of the generic
Yeah, but
interface you're
can I just
creating.
not pass that?
You could, I suppose you could try. Let's see. Racket,
Wait.
wire.
Gen port print, gen print. What are we doing here? Is this correct, Marinho? I think the syntax is we are missing maybe this.
Maybe if you could try putting the requires after the method definitions, that could help, I guess. I mean,
The
not definitions,
requires
declaration.
oh declaration. So you're saying to grab this. Oops. You're basically saying to grab this and put it afterwards, like that.
No, I mean, you know how there's define generics, identifiable, and then there's this the method signature down below in the next line, right?
Yeah.
So after that, you write requires, and then you put the list of things you require in there.
Ah, you're saying oops. You're saying to do that. that.
That could work, and if it doesn't, then we probably wrapped it in a list that we shouldn't have.
Line 78. No, it's still wrong.
Yeah, yeah. Try removing the parens from around the give identifier in the requires.
Oh, but the same order as before, or at the end?
Keep it at the end for now. Just
Okay.
remove the square brackets. Yeah,
No, still wrong.
wrong, man. It kind of sucks when there's something you don't use very often, and then you need to use it, and then you don't remember how it works. It's annoying.
Yeah, but it is totally a syntax thing. Because again, they don't have examples for it. But if you, I'm guessing here, the requires option may be provided at most once. When it's provided, any instance of the generic interface must supply an implementation of the specified required method IDs. Otherwise, a compile time error is raised. Wow, this is compile time. That's cool. I should check if the contract thing is actually runtime.
By the way, do you know to write a shell scripts with nicks that are available in the environment?
Um, maybe one day I did know.
So let me show you. I
I
did
don't
I was
think I know
checking the
anymore.
code. So here, you can make this inside your as a var, right? And then you let it be available in your shell, and then you can just call /execute, and then it runs.
Oh, so it's basically the equivalent of putting a program in a path.
Yes, but with the dependencies from nicks, right?
Yeah,
Not from
which
somewhere
which
else.
is probably better. Yeah. Yeah, the requires option should be okay. No, no, it's not down there. It's definitely not down there, Marinho. I think for sure is up here. For sure.
Question: which version of Racket are you using?
Um, the should I put Racket or Haku?
8.7. Oh, the requires option is added in 8.7.0.5. Uh,
Okay, there may be a solution to this though. What is the latest version of Racket full
it's
in Nix?
8.10. It's 8. Yeah, in Nix, I don't know. I know the latest release is 8.10. I know that's because Geeks updates Racket really fast for some reason. I mean, I suspect it's because Racket is a Lisp and Geeks is basically
Oh,
Lisp
right.
based. So,
Wait,
you
do you
know,
use geeks?
I use Geeks, yeah.
Oh man, you're 10 times more basic than I thought you were.
Yeah, man.
Oh
Geeks,
yeah, Racket is
um,
8.9, so this is a
Man,
problem with my flake.
I try to use geeks so much, but I work with .NET, so I can't even use.
oh, yeah, that would be a problem. I don't, fortunately, but
Yeah,
you
I,
know.
I like I could make the package for packaging .NET 6, right? But the point is the tooling. I need to package the debugger. I need to package the all the other garbage that goes along with .NET. So that's painful.
Yeah,
Wait, but
that's a lot of
would you
work.
be I didn't know you like Scheme, Magit.
Yeah, the point is not really the scheme. The point is the OS, dude. It's beautiful. They have Shepherd, which is their own. It's like System D.
I think so.
So they wrote their own, and it's called Herd. So, uh,
It's
it's
written
much
in Scheme.
yeah, and it's written scheme. It's easy to configure. It's really nice, man. It's
Also,
intelligible. It's like an extension of Emacs. Like
and
you're free to modify anything, and it's a good language. Just like not like Nix.
yeah, and Magetta probably likes Geeks because there's an Emacs interface for Geeks, and he likes Emacs, so you
Yeah.
know.
No, but you were talking to the Marin. You don't understand. You were talking to the guy that made Magetta made his Emacs configuration a Nix package and to be his
Oh yeah.
GUI, right?
Nginx. Yeah, Mage Max.
So like he was used to opening Discord using MetaX
Oh,
Discord.
that is no, but that is just EXWM, right? Because on Geeks it's much easier to integrate. I can do
Yeah,
that on Nix as well, but it's just more painful.
yeah, I don't use Emacs. My window manager is actually VSPWM, so
Mm-hmm.
it's a window manager that gives you literally nothing by default. It doesn't even give you key bindings, so it's useless if you don't configure it.
Okay, guys, we have a problem. We have a problem.
Yes.
To
Let me
What's the
tell you
problem?
to
what it
test
is.
this, I'm gonna have to update my Flake.
Good luck. Good luck.
But
Or
we
no,
have a
Wait, are
Magetta. We have a
you?
Magetta, which means
you
Uh,
that he has
can
a
you go?
computer with Nix.
Can you go to the flake?
Yes.
Lemos, you could temporarily just comment out the requires in the generic interface, and it
Oh
should
wait,
work.
no, wait. There's a easy fix, man. Easy fix. I think you just need to change the Nix PKG's input.
Oh, you mean
Uh,
here, right?
yeah, change to 23.05.
That's gonna
And
take
then,
ages, no?
no, it's just this package, right? But then go to the terminal, and then you need to do Nix Flake, I think. Update inputs. I think it's update inputs. Ah, man, wait, just a sec. I run this all the time.
But I think we just well, I'm gonna wait. If you run this all the time, I'm gonna wait. Nathan, you were saying that the problem name is Nix. The distribution that Marinhos uses is even more niched than
Oh, okay,
ours.
it's Nix Flake update. Just that. So it's gonna update the log
Which, by
file.
the way, you should all watch Zozin's last video, which is a Q&A, and he answers why he left NixOS there.
Okay. And what is his answer for me?
Uh, Basically what Nathan said.
Okay. Do you think it's up to date on that version? Look at the date.
It is. It is 23.05 is 8. It's version 8.9, so it should be
Yep.
okay.
Okay. Let's hope the package on Racket is newer on that.
No. The version that we need is 8.7.0.5.
Yeah, but I'm talking
8.9
about
is
the.
fine.
No,
Talking about
wait.
what?
What I'm saying is the package that you want in Racket is newer, right?
Yeah.
So I I'm just updating the Nix packages with the hopes that they bumped the package on that. You see?
Yeah, but I think based on my search here is that it is 23.05. It is updated.
Okay, so on the latest, they did right on the.
Yeah, on the not the latest. The latest is unstable. The latest
No,
is
no, no. Yeah,
8.10
what I say,
actually.
the latest stable, the 2305.
Yeah, that's updated. That's updated.
So the unstable is. Although I think everybody using
I use
just uses
unstable.
unstable.
I use
Yeah,
unstable.
it's just the evil mode that he thinks. Like Debian test.
I mean, you have transactional rollbacks, right? If something messes up in unstable, you have a safety
Yeah,
net, so
it's
why
it's
not?
just bad because you have much more work. I think like Lemos with his GPU, for example.
No. But that
Oh
that was
my god!
completely out of the rails, because
Oh, that's funny.
I needed to upgrade my NixOS, and
I
I had a
understand as
problem
well, but
that the
I'm lucky
forum
that.
post date was that day, right? That was
Mhm.
completely out of the rails, out of
Yeah,
question.
I'm lucky because all my drivers, I basically put my GPU to be Libre, so it's AMD, so
No,
I
but
don't have
mine
problems.
is also an AMD. I bought an AMD GPU first, Magit.
Oh, did you? Okay, so you are very unlucky then.
No,
Yeah,
no.
I got
What happened was the following. We had that problem with Nvidia. Then I got pissed. Then when I made my new computer, made sure to buy an AMD one to
Oh
not
right, I
suffer this thing.
recall. Yes, that you did.
Go on, Marin.
yeah, I gotta get on the AMD GPU train because my PC has a GTX 1650, which is a nice board, but it's NVIDIA, so Nvidia and Linux They don't go well together, especially because I'm using GNU Geeks, which,
Oh no.
GNU is even more annoying about non-Libre stuff. So, yeah.
Okay, there is something complaining about the submod. Yeah, this.
Check if he bumped the version, by the way. If he did on Nix.
Yep.
Okay.
Okay, problem solved.
Wasn't that painful.
Yeah. But I never seen the zero before. Have you seen the zero before, Marinho?
Let's see,
Unknown module.
submod.
What are you
Oh,
talking about?
did you remember to do a Racket package install again? Because Racket actually is a bit
Ah,
conservative when it comes to upgrades. When you upgrade to a new version of Racket, it actually it archives the previous packages you had, so you don't mess up
oh,
accidentally.
another thing, Magita, that you were not. I don't think I
Mhm.
mentioned to you. We made when we made the PR to add CI, we made sure that CI will only allow us to do changes now if Haku package install makes the project run.
Oh, okay, so you embedded it.
So we don't
Nice.
have to do it manually because we were just being completely and utterly grug and forgetting to put in the info.racket.
Oh, I see. I see. Okay,
Yeah,
so the
that's like
LSP could work now then.
Oh yeah, LSP works. Barely use it nowadays, but it works.
Let me see. Man, I
I'm so
guess
glad we
best.
made that
Can
happen
you
though.
press just A, Lemus? Just install whatever.
Oh, because I want to know the names.
Well, there are so many, man. I don't even. I would just give up.
Just give up. I'm so glad the initiative of making CI happen because now we can't just make the project break. It's got
Is that a good
needs to
thing?
work. Maybe it's not gonna work as we want because we don't have tests. Look how insightful the tests are.
that's
Uh,
very profound.
Maybe
uh,
very sad too, but
yeah, I'm gonna change that after we finish serialization. Okay, okay, okay. I know that error. That makes sense. Thank you. Thank you.
Yeah, I think when you exported the identifier, you forgot the letter E because
No, I forgot a bunch
yeah,
of things. What else? Okay, so this is the that and that. Next. Okay, 65. Serializable. Serializable. Provided identifier is not defined or require. What?
let's see, is not defined or required.
Okay, so I guess in the
Oh, right, because actually defining the interface when you do define generics, serializable just by itself is not actually defined as anything because like unlike structs where you have a type descriptor, right? I don't think there's an analog for that for interfaces. So serializable, imbitable without the question mark probably don't need to be exported.
yeah,
And
but it is
then
complaining in the contract. Okay, that worked. Okay, so that's good to know. Uh, okay, good to know. Line 15. Identifier already required. Interfaces. Oh, it's because of this. Oh, oh, wait, I see. Actually, gonna have to
right.
settle for this because there are things outside of modules. Okay, next. AST line 18. So it's complaining that the first argument of the method specification is not a name for a generic interface. It isn't?
Uh,
Now I am
did
even more
you,
confused.
let's see, require, go to the YouTube again, real quick. Just the
Oh, I know
invitable link.
why. I think I know why. Uh, because um, if you just do this, I don't think it's gonna import the internal modules, right?
Oh, right. Yeah.
But
It
now we have a
won't.
problem. How the heck we do the... Actually, what from it do we actually need? That's the question. So we are using interfaces and hashable, that's for sure. But are we using anything from this? So we are using define serializable, right?
Yeah.
What else are we using? We're not using this here. We we are only using one thing. So how do we import only one thing? I already forgot the syntax. Require Racket. How do you import only a thing? Yeah,
Good
this.
luck finding it.
There. So I guess this is the name of the module. In this case, it's gonna be... Mario, are you there?
Oh, I was muted. Sorry. Yes, I'm here.
Okay, am I doing this right?
Only in util and then build and the file name. Yeah, that's right. Yes.
Okay,
Yes.
actually I want to test. Are we using... No, we are not using that. What are we using aside from... We're not using that. Oops. Fix. We're not using that as well. I don't think we need this line at all. Yep. Nice. Line 14. Identifier already required.
Oh, it's because there's already a serialized
Oh,
function
that
in
there.
Racket.
Oh, okay. So Racket is complaining that we want to overwrite his serialize.
Yeah, Racket is actually nice because you um it actually warns you when there's a name collision, which is helpful but also annoying because your thing doesn't run. What you can do is, are you actually using stuff from Racket slash serialize?
Yeah.
Are you calling the serialize function from there?
No.
Then you can just exclude it. Like I'm pretty
Oh,
sure
that's another thing on the require, right?
there's an except
Except
in.
in. Yeah, that's right. Okay, let's use that. So here. What is the syntax again? Except in. Are you doing the prototype in eLisp, Maget?
I am actually on my own database trying to see how to do the structure for the indexing,
Sure.
the keys.
Is this a
And I
list? Can I
think,
put multiple?
Yes.
Sure,
man, I
cool.
think we will suffer a little bit.
You always say that.
Yeah. Yeah. I mean, this time I think I mean it.
Why are we gonna suffer? Tell me.
Data
Wait. You
structure.
said index.
Yes.
That's
Well, key, a primary key. Yes.
okay.
We need to
Okay.
do the primary key first. That's the
This
problem.
serialize the
Mm-mm.
There's also serializable there. Cool. Serializable. I thought it would be very easy to make a primary key thing, and I'm
The
not
problem,
joking at all.
the problem is not the idea; it's the data structure and how to handle it.
No, but when you say primary key, are you talking about literally indexing, like making it faster?
So what? No, no, no. It's literally identifying the. So what is the primary key, right? In the relational theory, it is not like a one field. Uh, that's something that people often do, right? You have like a serial field But that's not really a primary key. That's just a surrogate key that happens to be a primary key on like very easy examples. The problem is a primary key is like the ontological entity that identifies what the thing is. So that is to say the essence of this thing.
Mm-hmm.
Sorry, substance. So substance means what it is, right? So you're analyzing what makes this predicate inside the table to be meaningful. So remember that the table is a can be framed as a predicate, and the value inside the table, so a row, is a true value. So it is a it is they are it's the relation is basically composed of a placeholder that you can just pick the values and generate something that is true. That is the point. So the
Yep.
primary key, there's this quote that I like, which is nothing but the key, nothing out the key, and something like that. Anyway, whatever. But basically, the idea is everything should be directed only by the key. So that's how you know you're actually doing normalization, because things are bound to the key alone. So they don't have extra dependencies for other fields that do not belong to the key. So basically, that's composite. So composite key, let's say. So if you ask like what makes a I don't know, a table, that's not a good example. Like think of something you would store in a database. Uh,
Um, User data, I guess.
yeah, user and comments, let's say.
Sure.
So what makes the user the user? Well, I don't know, the username. I think that should be enough. So username, whatever. But then you say, okay, that's enough, but you have other unique values. Then those unique values, they can draw dependencies from other things inside the relation. So those are also part of the key. If they ontologically mean tables, so you just extend them. On this case, I can see anything. Like we gotta think of a precise example to make some judgment, right? But anyway, just think of this beautiful scenario, and
Sure.
then the what I'm thinking of how to store, why I think is not that trivial, is because think of our storage. We have the rows being written with a specific size right on the disk, and then what you do is basically you need to identify that by some conversion, right? That's the
Mm-hmm.
point of a, but that's the index. But the primary key happens to be one index, right? It's a way to uniquely identify where it is.
What
So
are
it's
the what
great.
other indexes people use aside from the primary key?
Well, there's like depends on the database, but like there's indexes for blobs, so you can index like bytes.
Sure. Okay, that
You
makes
can
sense.
index like there's the heap indexes. There are indexes that use a tree. There are indexes like it will depend.
You
Uh,
may want a data index, for instance, if you have data
yeah,
that's sorted
mhm.
across
You
time.
can even add, for example, JSON. Some people do JSON indexes as well. So it will depend on the use for what it is. But I think for us to make it easier, we can just do the tree index, a B tree, and
Mm-hmm.
maybe heap. And that's it. So
Sorry to interrupt you, Mageta.
no problem.
Marinho, I
Mm.
don't see
Procedure,
what's
by the way.
wrong.
Procedura. Is that right?
Yeah, that's right, because procedure question mark is already a keyword in Racket. Of
So you
course
make
it is.
procedura.
Exactly. But I'm not. It's
Well,
saying
that's
that procedure
Latin.
is not included in
Procedura.
the next required spec, which makes me believe
Did you
that.
remember to provide the procedure predicates from that namespace?
Okay. Gotcha. Gotcha. Okay, I need to do that. And I need to boot
Yeah,
the thing.
you're providing the builder, but not actually the procedure that identifies the thing you built. So that's the problem right there.
Yep. Right, go on,
And you also
Mageta.
have to provide the accessors and which you don't.
The exercer, what do you mean?
Table dash fields, table dash whatever. The
For
things
each one
you.
of them?
I'm pretty sure there's actually a helper for that. Let's see. I think there's a struct out in provide.
Okay, while you do that, I'm
See.
gonna fix the next error. Line 16. And by the way, I think EST is already fixed, which is astonishing. I was It's definitely gonna break because I just remembered that I didn't address that some of the serializations were being mutable, and then we are now returning two things instead of one. That would definitely break some code. Uh, but that we're gonna get there. So line 16. So table fields, providing the table. That's exactly what you said. Okay, we
I
need that now.
posted a link. Click on the link.
Okay, you posted the link. Sure. There. Struct out. Okay. Does this include also the predicates?
Yes,
Ah. Okay, that's
I think it
convenient.
does. If it doesn't, then it should. But it probably does.
Mm,
Yeah. Procedure. No. So we can. Well, I think I'm gonna provide for both field and type, so we can get rid of that. We don't care about data, so these two are not doing anything.
7.
Okay, next. Multiple bindings. Uh,
7 plus
procedure and procedure.
16 int. Oh, wait, sorry. Int 16 is 2 bytes, right?
In 16 is
Oh,
2
right.
bytes.
Because hmm.
This seems like a conflict again.
Yeah, because there's the built-in procedure from Racket, and there's also the procedure you're defining, procedure question mark, I mean. Let's see, multiple bindings, procedure question mark, and procedure question mark for a structure type identifier, which means
I think we're gonna have
oh,
to change. Well, maybe there's a hack to get around that because it's super bad that I can't. Well, I understand the problem. I'm not saying that this
like
shouldn't be a
I
problem.
mean, I mean, you can override a provider from the base language you're using, an identifier from the base language. In this case, it's Racket, right? So you can do that. It's just, oh, you see that require Racket slash base up there in line 4?
Yeah,
You can remove that.
I can remove the line or can do an except in.
Remove the line. Just remove the line. You don't need it. Everything in Racket slash base is also in Racket, so you don't need it.
Yeah. Okay, unbound identifier. That seems bad. Yeah, I am.
Oh,
Oh,
that's
this is written wrong.
because
That is written wrong. That's why.
yeah,
Line
you
18.
decided you don't like vowels. So
No, it's not about vowels. It's because the easiest one to keep reading it kinda ish the same is to change the I. But I really dislike it. But I understand that we have a problem with the name. Table row ID dash set. So line 37. Line 37. Okay, so probably something is wrong about that. Are we requiring the struct update? We are. What is the name of the field again? I'm pretty sure it's row ID. Yep, row ID. And okay, so is it set? I remember being set.
did you remember to actually call the thing that defines the helpers?
Call the thing that provides the helpers.
Yes. Did you remember to call? I think it's called no struct updates. Yeah. Did you remember to call define struct updaters? Because you kind of need to, otherwise you're not actually
Oh,
defining.
okay, so you need to go to the struct and add that there.
Yeah, and there's also a struct updaters out that does the providing conveniently as well. So
Uh, that's kind of meh, but okay.
oh, actually,
Can't we
there's
just
this.
put this in our macro? Like,
Um, I guess you could. You could. You definitely could.
we can just go copy this, uh, go here, go to the macro, add that, add, oh, not this, but add the require up here, and let's remove that. And then we can just copy this line, go down here, add it there, and instead of object we put name.
Yep. And then when you provide the thing, you can do where is it?
Provide what?
Instead of just doing struct out, you can use this instead.
Struct out, I don't know where you mean.
It's the very last thing in that second link I posted.
The very last thing. Like struct operators out combined with structure out provides all structure types bindings plus the bindings by define it by generate. Okay, so this define only generate those.
Yeah, the define will generate the bindings, and then you do struct plus updaters out instead of struct out, and you should be good. Oh no, that's not for the macro. That's for the provide when you're actually exporting the struct you built.
Oh, okay. Okay, so this is actually gonna replace the.
The struct out, yes.
Okay, okay, okay. Sorry.
And I'm literally going inside Postgres to discover how they do. And their code is scary.
Wait,
Yeah,
so
just
well,
write plus updaters in front of the word struct when you're yes, like that.
okay. Plus updaters. I have a question, Mageta. So are you saying that you couldn't think of a
No,
less
no,
enterprise
I am
way?
just going. No, no, I'm just read on
You're
the book,
missing
and then I'm trying
you're
to
missing
see
some
how they
R's.
do it. But I know of a way. Have a, but I'm just trying to see if there is a less dumb way. But
So we do know how to do it
the
dumb
smart
way.
way is too smart for me. That's the problem.
Yeah, and you have to require the struct updater thing.
That makes sense. That makes sense. Yeah, I
And
already
you're
got it.
calling a macro. Yeah, you're calling a macro from it, so you have to require it so you can actually use the macro.
Yeah, yeah. Oops. Probably didn't save this one. Okay, now we're talking. I'm really sad that I can't. Oh no, I'm not sad. This was just me getting confused. The
I by
syntax for fields is
coordination.
not the same thing as methods. That's correct. 943, it's in here. Unbound identifier. Okay, that gives me to believe that I need to go down here actually. I am exporting that. Which line? It's 58. 58.
Oh, and so. Oh yes.
What is wrong? Identifier.
Finish.
I looked away for a second. What's the next error
The
you're trying
next
to
error
solve?
is that it's saying that this is an undefined unbound identifier, give identifier. But I'm pretty sure this is exporting, right?
Yes, it is. Did
So
you uh did you require that module with the interfaces?
yes. Actually, no. Okay, cool. Actually, no. So let me go to here. Oops. There. There.
What?
That should work. I'm
This
gonna
is
remove.
one.
Oh, we need build file name. I think it's gonna complain now that we're importing things twice. Oh no, okay. 62. So it's complaining now about serialized hash list. Of course it is. Because we need to go here. No, not there. Here. And copy this. Oops.
4 plus 2. Ah,
62.
man, dude, making calculations of bytes in my head.
It's so bad, right? It's so bad. Imagine how much fun it was to make the serialization.
Oh, man, that's horrible.
This serialized hash list. Okay, now I am very confused. Which line is that? Line 100. 100. Oh, this is because we need to do the same here. I gotta say, it was very boring to do the math, but it was fun because it didn't feel like cheating, you know? Because when you have JSON, XML, even
Oh,
Racket's
yeah. Yeah,
built-in serialization, automatic serialization, it feels kind of like if it was to do this, like, eh,
if you were in the 80s and you had to,
had
well,
to.
you would probably not do it in Racket, but we'd probably doing assembly. Be
Which is also
imagine you
fun, don't
did,
get me wrong.
man, imagine doing a data. That's what IBM did, by the
Wait,
way.
your microphone cut for a
Oh,
bit. So
sorry.
imagine being IBM and
Like the IBM started the DB2 project, which was the first database with SQL stuff, right? Um, in assembly.
yeah,
Just
imagine that.
imagine the poor guys who started it.
Imagine that.
I
Oh, now the
mean,
language is breaking. Okay, that's nice. Go on, Mari.
if you're doing it in assembly, you could just as well like write a very minimal Lisp in assembly and
Yeah,
use
yeah.
that
They
instead.
use I think they use COBOL and C. In a lot of places. That's why SQL ended up being COBOL. 'Cause that's very tragic, actually, if you think about it.
Wow.
But like the core thing they did in assembly because they needed to for performance on the some parts, which was really crazy, man. Like, and they still maintain that. If you look at the, of course they don't share the source code, right? But uh, they still claim that a great chunk of it, and I believe that a great chunk of it is assembly because probably nobody ever touches that code ever again. Uh,
Okay, this is a dynamic language, so this doesn't mean much. But it is something.
It ran, so it actually works apparently.
No, it
I
doesn't.
mean,
For sure, it doesn't work. When I do this, it will for sure break to the races. But it interprets, it compiles. But I know for sure, I know for a fact that is wrong because again, I didn't fix the fact that now we are sending values here. I don't think I fixed all the possible cases and all the functions that this will break the thing. I fixed some of them. Let's
but
go.
not all of them. Okay.
Okay, we already expected this. Broke its own contract.
Oh,
Nice.
right, because some implementations like okay, so first of all, I'm not sure if you remember to add the size keyword to the declaration in the interface for serialize. Like I know you added the contract allowing
But it's
size to
optional.
be an optional, but you didn't actually add the size keyword to the interface definition.
Oh, I need to do
And
that. That's true.
yeah, and then the places that implement the actual interface needs to take that parameter optionally and then do something with it. Maybe ignore it, maybe actually use it for something, I don't know.
Wait, so the ones that don't care, they need to care a bit?
They just need to satisfy the interface. as declared. The interface says that it may receive a size parameter, so you have to deal with it if it arrives. So you know.
Well, I'm a little bit disappointed because I think that if I'm not specifically saying declaring it, it's because I'm not gonna treat it, and then it just errors out. And I need to add noise now just for the sake of it. But
It
we have a
will error
problem.
out, in fact.
What is the syntax for that? I have absolutely no idea. What is the syntax for optional stuff?
You have to put it in parentheses, and then
Parentheses.
you have to put a default value. Like the first thing in the parentheses is the name that you want to bind, and then the second thing is the default value. And actually, the keyword goes before the parents, not inside of them.
Wait, so the keyword goes here. And what is the first thing again?
The name of the parameter. It doesn't have to actually be the size. It can be anything else.
Um, but it's gonna be this.
Okay.
Okay, and now I need to go to every single definition of that. And only... Okay, and then in here I'm gonna put size like that, right?
You have to. I'm pretty sure you have to actually use the keyword size, like not the. It's not positional. It's a keyword argument now. So
Okay, so let me
I
copy this thing. Okay, for some random reason I put type here. This will never work. This is the only case that we needed. Uh, there, there. Oh, actually, we have Magetta now. We should ask the question.
Sure
Magetta.
do.
Um, I think it would be bad, but I want to ask you because you are the professional.
Certainly I am. Certainly I am.
So what happens if we pick one of the value informations of the model, which is like a string itself, like a piece of data, and we try to put we were thinking about adding the size information of a string into the string literal itself, because
Right.
before we were modeling as like
On the
when
type, right?
yeah, you only have that information in the type, and if you want to serialize a string literal, you need to receive a type.
Yes.
So I was talking to Marinho about, like, we were thinking about just embedding the size information into the string,
Mm-hmm.
but I said that my argument was twofold. My first one, that seems like a significant change in this, which means that we're going to have to think harder to do the migration from one thing to the other. Second, it seems like you're messing logic stuff with data stuff, because the size value is actually a constraint that we use to truncate and pad the stuff. This has nothing to do with
Yeah,
the value itself.
I agree. It's so here's my take on it. I agree with you. I think it is a, like, think of this. Uh, the 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 number is a constraint on the type, but you're adding on the data, right?
Yeah.
But since it's not leaking, so that's my point. Since it's not leaking forward, I see no problem with it as long as it helps the process, right? Because, for example, if it helps to eliminate uh, passing the type as a necessary parameter for serializing it, which I don't see happening. I don't know. Maybe that's what you meant on thinking harder, right? I didn't think of this, but okay. What would be the gain on doing that?
The
I
gain
see.
is that we would not have to have a serialization, a serialized method in our interface that has an optional argument, because there's only one single guy that requires the
So
size information to come from outside.
So you're saying is that for all the other types, a literal for, okay, makes sense. For a literal, like a int64, you don't need to know the type, right? Because
Yeah,
it's an int64.
yeah,
Right?
exactly.
So,
But think about
oh, that's
future
not only
proofing,
strings.
like
But here's the
globs.
thing: it's not only strings. Yes, blobs, photos.
Yeah,
It's
it
not
seems to me
photos.
that this information, like the real question is there a problem to have the information of the major problem to me is that I have a feeling that the logic and the value literal data
Hmm.
being
Here's
mixed
the thing. Yes, I see. I see. But here's the thing: meaning it's optional. Doesn't it mean also that this function can be casting,
can what?
can be shared for casting?
What do you mean by casting?
For example, you pass a literal for an int64, but you provided a type to be an int16. Then you're basically casting the 64 int to a 16. You see?
Effectively, yes.
So we could have that usage too being represented there. That's a
Yeah,
possibility
yeah,
because
that's
then
for sure.
you can have like some subtyping on the uh, support. I mean, that probably we'll have to do a type checking, a very dumb one, but we'll probably have to. Um,
Makes
but
sense.
that's giving the possibility of you using this. But I think I get the main concern because the point I think is more philosophical, right? What is the boundary in which by which it's allowed for you to break the abstraction to the point that
I
um,
would say it is philosophical, but I'm not 100% sure if this has implementation implications.
I'm not sure either. I don't see any right now.
I
I
think
think
that
it's a
for
very small
now,
thing.
like because we have guards and guards can do more than just verification. Because one of the things that I remember pointing out to Marinho is that when you add a value, you would have to
Mhm.
compute the length of it beforehand.
Uh-huh.
But if we are using guards, it doesn't matter because the guard can do the calculation for us, so it doesn't
All
matter.
right.
I don't know if there's any other implications. I don't see any other implication right
Yeah, I
now.
don't think so.
Uh, but yeah, the other point would be more philosophical of separation of concerns of like what is constraint and what is actually data. Should the
Yeah.
data be aware of its own constraint?
And which I don't know if it leads to a very severe problem, but I can't think of
Oh, I
any.
remember another problem. I remember another problem. Okay, so the one of the thing is when you are making your table, when you are making your schema, you are
Mm.
making the constraints. So I don't think we can only have the value with the constraint. We need to choose redundant, so both of them have the constraint, or only the type. Because that if only the value has the constraint, you would not be able at design time to make a
All
constraint.
right. True. That's true.
So you are defining your schema, there's no data, the
Yeah.
system is not running, and you want to make a table, and you want to see a varchar of only size 20.
You would need some reboot, right? To be aware. Some reset. Let's put it in.
Yeah, exactly. So my main concern, one of the things I think I also pointed that out is that when you're creating the schema, you're only concerned about constraints, and you don't care about values at all. The values are only like posteriority stuff. So um, we would have to rev in both places if you want to do that. And I don't know if I'm because not, and if you do that, we are running the risk of them being desynchronized.
That's true.
So that was the major argument. That was the major argument that I think I pointed out. Is that at design time, you would have to be
Mhm.
to have to create a dumb string just for the sake of having a constraint, which is not great.
Yeah, that's not great.
Uh, anyway, Marinho, the syntax is definitely not that, man.
Uh, expected, required,
Require
or
or
optional
optional identifier
identifier at
size
size
0.
0. Let's see. Uh, let's see.
Yeah, but it's just a parenthesis. Just a parenthesis. These type of discussions of like we are discussing if we should change the implementation details, but this actually has some like kind of profound
Man,
consequences of
here's
the model, mental model. That's so
man,
cool. That's so cool.
here's the thing that I hate the most in I was I was having a rant on this. I don't want to like hijack the session by the way with this, but
Go.
this probably could be a talk. I think I could give a talk on this. But anyway, the big in note is I was considering the analog computer and the digital one and how things started to be imprecise. Because something that pisses me off greatly is that everything nowadays in computer science is, yeah, I think this is better. And then it's like a circumstantial, right? There's no objectivity on anything. So the point is, I get that since most people are working with requirements for a specific use case, then you will have some subjectivity there. I am not complaining about those cases. That's applying logic to where it needs to be applied, which will vary, of course. But the point, what I'm trying to say is, people act and they develop abstractions as if they don't have any base for them, any foundation, and that leads to consequences that I think are very great. We can argue on the importance, all of those. I think one of them is very grave that I'll give a hook for the talk. Um, I was reading this book on the structure design from Edward Jordan and Larry Constantine. It's a very old book. It's from like the 90s, and the guys are very well old in computer science terms, right? Which really gives you a hint of why a book from the 90s is very old already. Because the technology changed substantially. Man, we're using keyboard as in I don't think so. But uh, we're simulating like a terminal from an IBM. I don't think so. But anyway, the point is that I'm trying to say is I read something that made me very perplexed. The guys they are defining every damn thing they are going they're putting forth, and they are pragmatics. So I was starting to think of the discipline that basically went evaporated with this idea of engineering in computer science, like software engineering, like discipline going poof. Uh, and then you start to think of like, okay, when computers were analog, uh, there was no room for this imprecision on the abstraction, just on the machine. We are blending both. That's my claim. So
Wait, that's
anyway,
actually really profound. Let me think about that. So what you're arguing is that the analog computer we were forced to have to follow the abstraction because well otherwise we would be screwed.
yes.
Like the cannonball would hit the wrong ship and then well things will go
We
wrong.
hit you probably.
That's okay. And then
No, that's not okay, man.
I think I would rephrase it and say that the digital computer brought more freedom, and then only the wise ones will know how to not let the
Like,
foundation
think
let
of.
fall
I
apart.
think it's broader. Think of what is a computer, right? So people say, "Oh, an abacus is a computer," and then you look at a computer today, like what I'm using right now, and man, like, how is this thing an abacus? Like, and then people miss the point, which is we correlate these two to be computers because they do they complete the same end goal, which is to do computations. And then an abacus can do computations, is just extremely less efficient at that than this thing here, right?
Sure.
So but both do this, and one is manual and mechanic, and the other is digital, right? um, so but both share this abstraction. So my point, what is the abstraction that is being I think this abstraction of a computer that I think is much easier seen in a mechanical one because it's something you can see, right? You can touch. It's
You
a
can
bunch of
touch.
cogs running.
Yeah.
I seen it.
It's pretty cool, by the way, Nathan. If you've never seen the video of analog computing, it's so awesome.
Man, I have one, and here's the if you look at people like there is Ramon Lu in the medieval era doing if you look at his mechanism for lottery, it's really insane, man. Like he did basically an algorithm and developed a discus that would run with a bunch of cogs, and then it would when it would stop, it would give the solution for his combinatorial problem. It's really insane. Uh, and then you have like Charles Babbage and uh, like Pick Bull, for example. He did the entire Boolean system based on Aristotelian classical logic. So these people, they knew that the computer was just there to map abstraction. It was an abstractive machine, right?
Yeah, but
And then,
people would never ever agree. Like, this is a very hot take. You know I agree, but you understand that people go crazy about it.
well, I don't think you can disagree with this. A computer is a machine to incorporate algorithms, which are abstractions by definition.
No, I
So
understand that, but every single time you mention the word abstraction, people will start to go crazy about
uh,
it.
if you,
They would just like, I don't know about. No, they will say the following. They will say that they want concrete stuff. They will say that. They will also say they want something that they can touch, which is fair. Wanting stuff that you can touch
yeah,
is fair.
which is oh man, which is essentially what I said.
Yes, yes, that's for sure. Uh, but I think
Anyway,
that
we can make that a talk, man. That would be really
no, you
nice.
should make a talk about it. But the thing that I'm mostly, I wouldn't say pisses me off, but it gets me sad, is the fact that
Well, I exaggerate terms. I don't get peace by it.
is that people people are afraid of it. Like, because it's something is abstract, they already imagine that it is be something completely convoluted and something that they cannot comprehend at all.
Yeah.
And then if they have that impression, we are just screwed because legacy will be the mandatory all to 100% solution for most of things. So innovation will be threatened and all that stuff. It's so freaking sad. There is also the argument of abstractions for this fanciness for the sake of fanciness, which is the one that one pisses me off because you're basically saying before you even understand it that just because something is different and usually it tends to be a little bit more abstract, it's fanciness for the sake of fanciness. You don't even know what you are talking about, but you are saying that. That pisses me off quite a bit. Uh, I must be doing something really wrong here. Generic method definition has an incorrect arity. And then for the one that does care about it, you can do something like this. Not only people don't accuse that for Haskell only, Nata. People accuse OCaml, SML,
I never said anything.
everything that has
I can
everything that is
see.
related to any theory actually.
Lisp
Every
even.
Lisp, everything that is related to any theoretical background, people will complain about it. It's a fanciness for the sake of fanciness. And some of them may be fanciness for the sake of fanciness, but you can only judge that after you know them.
Yeah.
That's my point. The ones that we care about. What is the false for, Marinho?
Is to check if we actually got a number as the input. If we don't, like if we don't pass the size keyword, it will default to false, which is in Scheme, false is the only value that is actually completed as false, unlike closure where false and new are both false. So
Oh yeah,
just for the check.
that is also a thing. That is also quite a thing. Um, okay. Okay, that fixes it. Okay, arity mismatch AST line 97. So are you reading? Are you reading the Postgres code, Magit?
I am actually running my client and querying Postgres, the protocol, to understand stuff.
That's cool.
That's sad, actually. The
No,
protocol is
yeah, it's not because
man.
it's sad.
I'll
It
share
wouldn't be
to you.
cool.
I'll show you the page of their protocol. It's horrible. It's like you can totally see legacy garbage from like the 90s that they just stretched, and then it's horrible. Like it's
73.
inconsistent across the multiple entry points. Bad.
Am I doing things correct?
I think there's a place where you call serialize with two arguments positionally instead of the size keyword.
But it's saying line
Which
73. Oh, you think this is
yeah,
only the backtrace? Maybe. Like Uchu 118. Let's go there. It is possible. 118. 118. Oh, it's this. Definitely this.
serialize name with the name, and then serialize name does. That
Oh,
doesn't seem
serialized
right.
name is a function. That's
It's a
correct.
function. It's a function.
Yeah.
Huh.
Okay, so AST line 97 as well. Let's go there to see what the heck's happening there. 97. Yeah, this
Four.
is
4 does it make
Uchu 112. Arguments type var char 7. Wait, what? Type var char 7 is this is in the main entry point, I think. Yeah, for sure. See here?
Type
What?
varchar 7.
What?
Wait, that's an argument. Arguments are procedure type and then type varchar 7.
I'm so confused right now.
man.
Let's actually go from the beginning. So IO 58 write schema to disk. Okay, so I think everything else is working. That's great. So line 58 here. Then line 59 there. Okay. That is calling serialized hash list. That is happening on line in this line here, line 63.
And then serialized hash list is doing what exactly?
Then this is probably this serializing a table. That's why it's going to line 97 in the AST, because probably that's the serialization of a field, and the table is composed out of a field. No, it's actually calling the table serialization. So this is actually serializing the entities of the schema. So this is calling line serialization of the table, which is okay. And this is then asking for the serialization of the field, which also makes sense.
Man, I'm gonna go insane with this.
You can wait for us if you prefer, Magit.
No,
don't go insane.
Dude, I finished, but it's just horrendous. Like, basically the point
It's
is
horrendous.
you gotta pick the things on the protocol by bytes. So if you mess up with like 1 byte, like if you consume 1 byte that you shouldn't, all the messages on the string get misaligned, so you read everything wrong. So you need to be basically trying like what to read. It's awful.
Oh, that's awful.
So I need to keep
That's
doing
awful.
math. Like, oh yeah, this field here I can get it by +5 minus this other field, or 5 plus 2 by the size of this other 2 bytes. Oh, so it's yeah.
Not a great experience.
Terrible.
Uchu
Oh,
line.
it's on line 76. Line 76. I
Oh,
think.
okay, that's a good catch, Marinho. So what is wrong here?
Well, first of all, you're calling serialize, right?
That's okay.
The problem is the second argument is not being passed with a keyword, it's being passed positionally.
Wait a second. I think this is double wrong, not only wrong. Oh yeah, this is double wrong. This is this, and then what we actually need to do in here. Actually, it's even better to it's just better to just do this. So field type self, and then here you do type, and then type byte size type.
Ah, man, I will burn some
Okay.
memory. Okay.
One last thing. That's you fix the problem that made the crash, but it's actually still wrong because you're calling serialize, right?
Sure.
But that's the function you're defining. So you're not actually calling the generic version of serialize. To actually do that, there's a helper you gotta use that's called define slash
Oh
generic.
wait. So it doesn't know which serializes this based on the type of this?
No, it actually knows that this serialize that you're calling right there is the same one you're defining because
But it
it's a
isn't.
define. No, it is.
No, it shouldn't be. That's what I mean. This is the serialization of the field. I want to be using the serialization of the type, which is up there.
Yeah, you actually need to use this thing then.
Okay,
Which,
so it assumes self-reference by default.
yeah, it assumes self-reference. Actually, it just assumes that you're defining a plain old function, and plain old functions are not generic. So if you actually want the generic version, you have to ask for it explicitly.
I need to ask for it explicitly.
Yeah, see, define slash generic, you put it over there next to the there's an example you're with the mouse right next to it, but
Here?
yeah.
Ah. So this is I am calling it.
Yeah, you're actually saying, look, in my definition of gemprint, I actually need the generic version of gemprint inside of it. So give me that, and I'm gonna call it superprint instead.
Ah. Okay. I see. Does this go? I think does this go here?
It actually goes inside of the square brackets, inside of the
Ah.
square brackets.
Okay. That's actually kind of cool. So I'm just gonna say serialize here, and then in my particular case, I'm gonna put type serialize.
Yeah, you happen to know it's gonna be the type serialized, but in general, you may not know, so it gives you
Super,
the generic version.
super. Oops.
Hyper.
Super serialize, and then I pass the type, and then it's gonna know that I'm talking about the generic one.
Yes, yes.
Ah. Okay. So you can actually have multiple interfaces with the same name, and just name them differently.
Um, I guess you could. I'm not sure why you would do that. I mean, the thing that's important about the interface is that the gen colon whatever that thing is the interface descriptor, right? And you need it in order to implement the methods in the struct. So if you just take care not to let those things collide in your namespace, you should be fine, I guess.
Okay, this is good news and bad news. I think the good news is that probably given this error and that we had this print, this is only a matter of like byte manipulation or whatever, or we're not. But again, it's exactly what Magetta said. You need to keep track of the math, right? And this
Yes.
error means that the math is wrong. Uh, uh, but I think this is a win anyway because we are basically 90% done with the migration. It's 90 now instead of 60.
That's good. That's good.
Okay, I think we should stop now because it's almost like 2.5 hours, I think.
Yeah.
Almost 3 hours.
I gotta, yeah, I gotta do some other stuff still, and
Yeah, I'm gonna
and
stop the
and we
recording
got
now.
work tomorrow.